Welcome, and thank you so much, Jos, for the kind words, introduction words. I'm very flattered. Inspector Equitandi, I will teach you how to say that later.
Oh, well, thanks you.
Don't worry. And also, it's a great pleasure to be here, and also congratulations to Jos and his team and everybody here involved in the NMCB project and consortium. I think it's a very impressive setup and for a very challenging task, but also a very important task. So I was asked to just give a brief overview a bit on where we are on the knowledge on ME/CFS, and I will touch upon a few things that we are doing currently also in the end. So we have a short time slot to do all this. I hope I go through it not too fast for you, but I'm also open for questions afterwards, of course. So let's start very basic, and I think all of you who are here are probably well aware of what ME/CFS is in principle, but I think we can't stress enough the classification of this disease and disorder, specifically for our colleagues, our politicians, and people around us in society who doesn't really understand what it is and don't accept what it is either. So it is a neurological disease, in most cases being engaged by a post-viral initiative, or it's a post-viral disease effect in many cases. It's not been documented for all patients, of course, so there's a question mark there, but we think that most of the patients we see have a post-viral problem. We know genetics is important. We know that environmental factors are important. We know that life situation is very important. So many factors. We are complicated organisms. We are not an animal model. We are very complex, and we live our lives, and we have different opportunities and challenges in life. As you know, the symptoms are multi-organ, affecting every organ in the body, more or less. So that also makes it very complicated to understand what is the reason behind the disease, what can we do to find a cure, and what can we do in treatment. And I will come into that a bit. But you've probably seen these lists of symptoms before: post-exertional malaise, being exhausted after a mild or even very, very small exercise, is a hallmark for the disease. And this is very important for us when we target and put the diagnosis on our patients, that this is something we follow, and it's a challenging thing to follow in some cases, but it's definitely very important to take a note on that situation. Persistent fatigue, sleep disturbances, pain, central or peripheral pain. Neurological diseases or cognitive symptoms that I monitor a lot, since I have my background in that area, is of course the brain fog, the confusion, disorientation, difficulty in concentration, short-term memory issues, ataxia, muscle weakness, and hypersensitivity to noise and light, or other stimuli, as you all know. Then when it comes to autonomic, immune-related, and digestive tract symptoms, there are also plenty of them, and orthostatic intolerance, for instance, is one phenomena that we see in many of our patients. I think you know, but we have to tell the world, this is not an uncommon disease. We have many, many million patients around the world. You can assume that it should be at least 20 million. I would say it's probably higher. There's a hidden patient cohort definitely here on a global level that's been diagnosed with something else, or have complicated combinations of other diseases, endocrine disorders, for instance, combined with ME, and then they may be treated and diagnosed as endocrine disorder patients, but you miss out on the ME symptom part and the diagnosis. US, we say around 2.5 million patients approximately, rising now after COVID pandemic. And you also know the situation for many patients, very hard situation. So 25%, 1/4 of the patients are more or less totally bedbound or housebound at least. And then we have, of course, well-functioning patients that can attend studies or can go to work part-time at least and keep up with a fairly daily activity, but will always be forced to keep their energy balance and to think about what they're doing. And then we have the middle portion of patients who can maybe not attend work or study, but do the daily activities. It's twice as common multiple sclerosis. Multiple sclerosis is a disease we typically compare with, specifically in neurology, because we know now much more about that. It's one of the, I would say, unique situations in neurology where we may almost claim the cure, not for all MS patients, but you. By instance, actually, sclerosis to a large extent, even have cases of patients who are the 5 years relapses. So that's a dramatic change. It is otherwise rather depressive in the sense that we do much. We can concentrate on trying to help the patients in the way we can, but you know, it affects everyone: men, women, children, anytime, anywhere in the world. We know it's more common in women, as I will come into. I was asked to give some sort of perspective, and is this a new disease? Well, we know it's been around in literature for a long time, and actually, if we look back into history, the beginning of 1900s, we see that there have been outbreaks of epidemics that has sort of ended up with something we could maybe claim could be partly at least connected to ME/CFS. And I highlighted three different indications or outbreaks here. Now we focus on Akureyri disease. This disease, ME/CFS, for some time was called the Icelandic disease also, because they didn't know what it was. At that time, they thought it might be one new type of polio that was expressed. And it's a rather interesting story. I won't have time to go into all these details. And I got this slide from a colleague at Iceland, Friedbjörn. He's a very good and nice colleague. And just focusing on the Akureyri disease then, or ME/CFS, after the outbreak in Akureyri. It started in a college, in a school college among youngsters in Akureyri up here, and it was in 1948-49. And at that school, it was a boarding school, so they had a lot of students living there. It spread and it caused effect on patients, 465 cases at that time. Around Iceland, many of the patients or the children at that time, school kids, left the school and went from there to their homes out in Iceland. And in the end, afterwards, they collected about 1,000 patients with that same outbreak population then. Then there was a later outbreak actually on 2 different locations. You see the blue circles here in the 50s with much less cases. But I had this last year actually. I had the possibility to visit the school actually. It's still a boarding school and a high school now, gymnasium. And together with Friedbjörn, we had the opportunity to climb up onto the attic. And in the attic, they have one of the rooms where the dorms where the students were living still kept as it was. A rather poor situation. I can imagine being sick in the winter, staying in these little rooms, left alone more or less, because they didn't want to, they didn't know what it was. So they was afraid it was some spreading disease that they would carry out from the school. So students were more or less isolated there. Also, I had the opportunity to meet one of the patients, Asgeir. He was a student at the time, and he was affected by ME/CFS then at 1948. And he'd been, as he told us, he's been a very fortunate and active person in himself, and been successfully living his life, as you see. But he said that after that hit in 1948, he never really could come back to his performance again. He was very good at school before, he couldn't start his studies again and so on. But he managed, and he has run a very good and rich life anyway. So what do we actually know then? As I said, in most cases, we say we are careful, 60 to 70% of all cases are post-viral connected at least. We know that it's more common in women, 2/3 at least of all patients are women. We know that there are central nervous system and also peripheral autonomic nervous system damages that could be actually measured to some extent. We know that the metabolism, and especially the energy metabolism, is affected. And we can look at mitochondria, the organelles in the cells that produce energy, and we can see that they are affected in their function. We know there is altered immune phenotypes and functions. If we look at subpopulations of the immune cells, we see that they differ a bit within the ME patients compared with healthy controls. And we also know that there is an expression of autoimmune antibodies. So the body's immune system start to produce antibodies against substances or proteins, in this case, of our own body, and causing an autoimmune effect. We know that there is quite a lot of studies on the gut microbiome, for instance. There are documented changes there. There still need to be done more research on this. I think it's very important findings, but they are hard to reproduce and it's hard to follow and hard to know exactly what to do with it. And also there are a few papers now on gene expression changes and epigenetic changes that I think is very relevant. Still need to be researched more before we understand that. The list of what we don't know is actually quite long, but I shortened it a bit just to make it digestible. So we don't know exactly what is the disease mechanism. Why is it so multi-organ involvement in this disease? So what is the common factor here? What links do we have to that initial trigger or triggers? Which could, of course, exist. There could be an infection combined with trauma, with a stress-related situation, or something like that causes it. And, of course, genetic factors and other things. So, but what we would like to see, of course, is an exploratory model. Because if we can understand the biochemistry or the pathophysiology behind the disease, we can also maybe at least faster reach treatment and a cure. So that's the goal in the end, as you understand. So in our case, we have our focus a lot on neuroinflammation. The neuroinflammation is one part of the story, at least. We know that in the central nervous system, we can see not extreme inflammation in most patients, but we can see a low-grade inflammation that continues long-term over months and years. And we can see that low-grade inflammation causes a disturbance in the repair mechanisms in the central nervous system, but it also sends triggering factors to the periphery that probably also gives other inflammatory processes, dysregulation of circulation, pain-related effects, etc. So, of course, you are what you are. I'm interested in the nervous system and the inflammation, so of course I look in neuroinflammation. If you're especially interested in the gut, you look at the gut. And if you're interested in kidney, you think kidney is the most important organ in the body. And that's how it is, of course. But the brain, I think, definitely is involved in this. And the picture here, not to complicate things, but we have in our central nervous system, we are supposedly not having inflammation very often. The central nervous system is, as a few other organs, are what we call immunoprivileged. So we shouldn't have activity of inflammation there normally. But when we get it, that can cause quite a lot of damages because we get scar tissue formation and we get degradation of nerve cells or astroglia cells, the supportive cells that we have in the central nervous system. And that can also affect the endothelial cells, the blood vessels that are in the body. And the internal lymphatic system, the flow of immune-related molecules in the cell, in the brain will be affected also. So, of course, this is nothing we want to have. And inside the brain, we also have a dormant immune cell, you could say. It's called microglia. It's a small supportive cell, but when it gets activated by an infection or inflammation, it starts to change its character into immune cell related or similar to immune cell activity, and start producing immune related molecules, transport or signaling molecules. I will get back a bit to that soon. So what I prefer, if I can, to start is the cerebrospinal fluid. This is the liquid that surrounds the brain, and if we can get a sample of that, we can of course then have the opportunity to measure the biochemical reactions that happens inside the brain. It's an invasive sampling technique, so of course not for everyone, nothing you do at home. And I think that is a challenge to get enough material and enough patient cohorts to study with using this liquid. It would be much easier if it would be a blood test or a saliva test or something like that. But still, we think there is a great value to do lumbar punctures, and we've been working with that for many years now. And how I got involved in ME/CFS specifically was because of my interest to study neurodegeneration and neuroinflammation following cerebrospinal fluid. And colleagues in US contacted me and wanted me to look at some patients with ME/CFS at the time. And I had to go back into my neurology book and check if there was anything written about this patient cohort. It was like 2 sentences saying that this is something very unclear. And that triggered me a bit to understand that better and be part of the story. So in this study we published many years ago now, we looked at the differences between healthy individuals and post-Lyme disease, tick-borne infection, and chronic fatigue syndrome. And we saw similarities and changes there. And we just recently, with the same team actually, with American colleagues, published this paper where we have looked at fibromyalgia and ME as comparison. And when we look at cerebrospinal fluid, the overlap is very big. So there's not much differences between fibromyalgia and ME/CFS patients when we look at the biochemistry situation in cerebrospinal fluid. You can interpret that in many different ways. 2 related diseases, yes, but we claim that fibromyalgia probably have a more peripheral onset and activation than ME/CFS, has a more central activation. So what we are doing now in recent studies, this is one example. We are doing collection of ME/CFS patients, following them with a lot of different sampling, including cerebrospinal fluid, doing brain imaging. This picture here shows image of a patient from underneath. You see the nose on the top there and the eyes. And we look at the intracranial pressure inside the brain. And we have seen that not all, but quite a few of our ME patients have an increased intracranial pressure. And we can see that by looking at these pictures. In the cerebrospinal fluid, we see and have repeated the findings of low-grade inflammation markers. But we also see that some of the repair systems are not functioning as they should. And in the metabolic profile, we also see the energy deficiency problem in many of our patients. We see that the production of metabolites that are related to energy is not functioning as well as it should compared with controls.
Jonas?
Yes?
Sorry to interrupt, but we have 5 more minutes.
5 more minutes. Oh, jeez, give them extra. I will go a bit faster. Yeah. One thing that we discussed before lunch was option to follow patients and collect. And the initiative here is, of course, to generate a biobank of materials and to be able to include severe patients. It's tricky to have them come into a clinically sample. So we have done now, over the last 2 years, doing home visit studies. And this pretty complicated picture shows you that we have done it on 2 locations in Sweden and together with a colleague in Australia, Chris Armstrong, who's a colleague at the Open Medicine Foundation also. And basically last week, I think we had all 3,000 samples that I've generated in Sweden now, fully screened with metabolomic profiling. And we have done that with absolute quantitative measures. So we now have about 1,500 metabolites mapped in these patients and controls. And contrast group is an athlete group. They are the tennis pros in Sweden. You know, Sweden, Björn Borg, Mats Wilander, traditional old Swedish tennis players. We have had the chance to have the Swedish tennis team to support us with giving us their samples also. So they are a highly trained contrast group, let's say, not a control group. But what we've done over the visit at the homes, we have done collection very frequently, as you see. All the stars here is blood samples collected, miniature samples. And we have challenged the patients and controls, and that is with 3 different tasks. One is you could say a memory test, exercise test being the last one, and a social test in the middle. And we are now looking at what happens in metabolism in these over this time. And we already have some data. I won't have time to go into them, but we see that, for instance, lactate pyruvate ratios and other things are related to metabolomic profiling of mitochondria is affected very much in the ME patients, especially with the exercise, which is a mild exercise. Well, one other project I have, 2 more projects I'm very excited about. One is the imaging project. I will go very quick on this one. Just the reason for that is we know that with other infections, SARS-CoV-2, for instance, or herpes encephalitis, we see quite dramatic inflammation in the brain. But we think that this may occur at least at some time point in ME patients also. You know that many of the patients have initially an Epstein-Barr virus infection or an herpes virus infection. And maybe we can monitor that. And we have now set up we jumped the conclusions of a published paper already where they found this brain atrophies in COVID patients. We have set up a new method for diffusion-based MRI in Uppsala, which will hopefully then help us target microglia activation in our ME patients. And this is something we can repeat and repeat and repeat without any disturbances of the patient. So that is going to be very interesting. And I will jump the picture of how it looks like. Targeting treatment, I think that is the goal for us, really. And I just want to mention that we just started the clinical trial called the LIFT, Life Improvement Treatment Trial. And this is a combination trial where we treat patients with Mestinon or pyristigmine and LDN, low-dose naltrexone in combination. And it's a fully randomized double-blind study, and we will include 160 patients. And this is run together with Dr. Systrom and Dr. Chow at Harvard Medical School for different reasons. We will do full screening. We will biobank all the samples. We will also do metabolomic and proteomic and other biomarker screenings. And we will monitor the patients. They will actually be monitored over 4 months at least with blood draws, with surveys, and with activity measures, plus brain cognition measurements. And LDN, I don't go into what the mechanism is for that, but in this case, we're after the anti-inflammatory and analgesic effects. Mestinon is an acetylcholine esterase inhibitor. So what that makes is increasing acetylcholine, increasing norepinephrine, affecting, for instance, cardiovascular output and oxidation or oxygenation in the blood, but also helping with orthostatic intolerance and being shown in low dose to give anti-inflammatory effects. The patients will go through a physical exercise test, a shape test. This is a well-trained physiotherapist who's doing this rather fast. Patients will do this much slower and not as long-term as this one is shown here. We will do surveys. We will use the FunCap survey that been presented by Christian Sommerfeld and other colleagues in Norway. And we are very happy that we now have that tool in our toolbox. We will do brain cognition, neurocognition measurements with an online device from Dana, Brain Vital. And we will ask the patients to carry activity measures. We were thinking of using the Oura Ring. It's a bit too expensive and complicated now with the subscription for the patients. So now we carry the Garmin watch instead, or we collect brain or vital parameters by that. Oops, sorry. So this is the first in a long line of trials that we are going to conduct under the umbrella of Open Medicine Foundation. And we have a long list of interesting targets that we would like to approach. But it's very important that we do it in a solid, double-blinded fashion, as we know, so we can show the evidence, and that evidence will help prescription of functional drugs around the world later on. So that's a really important task. But we are also interested in non-responders here, because maybe the non-responders can also give us insight on what is happening with those. Why aren't you responding on a treatment where maybe a majority of patients will respond? So that's also going to be important for us. And I think, oops, sorry. Now I jumped. This is the treatment study, so I will end with that. It's the final slide. And this is the horse, just to tell you what the title that I'm maybe most proud of, actually, is this Inspector Eketan is a head of the horse department at Uppsala University. It started in 1663. So it's very old. I don't know how old is your university. It's fairly old.
Should know, with round about that time.
Yeah, so our stable is as old as your university.
Wow. Good one.
Yeah.
Didn't see that coming.
And of course, support from patients is super important, and relatives and others that support us with their sampling and possibility to measure things. And funding, of course, is very important. So thank you very much for your time, and I'm happy to answer some questions, maybe, if we have time. I don't know.
We actually don't.
No.
So maybe you could leave your questions for the coffee break.
Yes, I will be around for the afternoon, so please ask me questions later. Sorry for overshooting the time here.
Okay, thank you very much. I think that I was just telling Jonas that he made our job so much difficult because of his brilliant presentation. So bear with us. Yes, we have been working on the UK MECFS for more than 20 years when we started working at the London School of Hygiene and Tropical Medicine. So I'm Eliana and my colleague Caroline Kingdon, and who is there. We started this work on developing a biobank, or in establishing the first MECFS biobank. So why to establish this biobank? The UK MECFS biobank, we started with a consultation process with patients with MECFS, including the severely ones. And then we designed the protocol informed by the patient community. And the biobank is currently an open resource that has been sending samples to around the world, basically. Oops. Okay, this should be some consultation process. And sorry, I don't know what is happening, but yeah, we started drafting the protocol with the community of patients, and we have defining the potential participants for cases and controls. So the cases, we decided to work on people who were 18 to 60 years old, and the up limit is mainly because we were working on a team of immunologists, and we know that after 60 years old, it changes a bit. So we wanted to compare this population, and the under limit for 18 is because we didn't have a pediatrician with us. So this was our population basically. And we recruited people with mild, moderate, or mild/moderate, and severely affected people, including those who were bedbound. And we go to their homes to collect blood and do clinical assessments. So they were not able to attend the clinics that we had. For controls, we have two cohorts, one of healthy controls, like normal people, not very fit, and the ones with multiple sclerosis. And this is why, because we wanted to have a disease control. So we managed to recruit a cohort of people with multiple sclerosis that we could also compare. And these groups were matched by age, sex, and area of residence in the UK. So, a biobank, there are some issues that we consider very carefully, we have to consider, mainly the legal and ethical aspects, and there is a lot of potential dangers for misusing data and samples. And when we did the consultation with people with ME/CFS, one of the issues that they asked us was about how people from the government could get our samples. And it was kind of legitimate concern about DNA samples and how people could use these samples and blah, blah, blah. So these are the dangers of misuse and the potential benefits of getting resource infrastructure that could help to understand this disease. So when we have all the ethics in place, we started the invitation of participants, and this is the main outline of how we recruited participants. Initially, we started recruiting people from the NHS, the National Health System in the UK, for primary care and secondary care, and the severely affected usually were through some groups that support groups, and some disease register that we had. And the controls were for the same population, NHS primary and secondary service, and we invited, some of the controls were invited, particularly the partners of people with ME/CFS. We didn't want siblings or, so this was to have a very robust control group. Then we have a clinical assessment, and from the clinical assessment, we could exclude the potential participants for various reasons, or it could be a probable case and control, which is the second line, the recruitment of consenting participants. Then we organize the sample collection, and with the collection of blood samples, and we have a urine sample just to exclude any urinary infection. And then we have a pool of lab tests, normal lab tests, to exclude other conditions that could explain the chronic fatigue. Once we have that, we have the confirmation of diagnosis, sample processing, and storage. So we partner with the Royal Free Hospital and the UCL Royal Free Hospital. They have a biobank, and we started sending our samples to processing, aliquoting, and storage. And we end up being the largest collection in the UCL hospital. So at the end of the day, we have the confirmed cohort of people with ME/CFS with mild, moderate, or severe cases. Non-ME/CFS, for those ones, we already have collected the samples. So we have a subsample of non-ME/CFS with chronic fatigue that we use as control group as well. We have the healthy control groups, and we have another disease control group that it's the MS cases. So this is how it looks, the Royal Free Hospital storage. And we, apart from the storage, we have the QME database that is dedicated, and we started entering all the data from the questionnaires in paper, and Kate knows quite a lot about it. But now, finally, we managed to get a very good team of IT, and the patients are entering their own data. And yeah, they have a specific number. So they know this number, anonymized, is composed of 6 letters and numbers. And they can do all the questionnaires online. So basically, what we have in terms of data, we have data from questionnaires, from clinical assessments, and from the results of blood tests. Yeah, I don't think that I go through all this, but you can have a look that the questionnaires, we have the symptoms, sociodemographics, individuals and family histories, potential risk factors. It's a quite long questionnaire. We use the GHQ-28, scores of fatigue and sleepiness and pain. The clinical assessments, we have the urea analysis when we go to the patients. And we have some blood that for the main blood tests that are in the last column. So we also have pulse oximetry, blood pressure, sitting and standing. We didn't find many differences, but we still have all this data. Measurements of standing, height, weight, and bioimpedance that we also don't use much this data. There is no much difference. Waist circumference and hand grip strength, that these are one that it's very interesting to look into the studies. So in terms of holdings, we have whole blood, serum, plasma, red blood cells, PBMCs, blood specific for RNA. And currently we have more than 36,000 aliquots. All the samples are processed and stored within 6 hours, which is not the ideal, but this is because we may now, Caroline is going up to North England and collect the blood samples and rush to the biobank to be processed and stored. So the users of the biobank, meaning the researchers, usually they have application for us. And this outline application is reviewed by the UKMEB Guardian Board. So we have a Guardian Board that are comprised by one researcher, one people with ME/CFS that are part of our steering committee, and one person from one of the charities in the UK. So if the outline application is accepted, this is reviewed by the ethics from the Royal Free Hospital. And once this is done, we have the signature of the material transfer agreement, the MTA, and then we can have the shipment of the samples. We have been sending samples around the world. We have sent samples to many universities in the UK, Brazil, Spain, Israel, some of the European countries, USA, Austria. Well, you can see. So these are the samples that we have been sending on top of doing our own research. And this is Caroline.
Yes. Actually, that last slide is very out of date. We've sent to a lot more people since then. So that's the theory of the biobank. And I'm the one that goes and sees the participants often. So I'll talk to you about the reality of the biobank. So what you have to remember is you're going to see these people, or you're inviting these people to see you. And particularly if they're severely affected. They're very isolated. Relationships have broken down. They live a very poor life, not rich in experience, not rich in people. Marriages break up, children desert them, parents neglect them. And very often it's just the person and their carer. And the carer sometimes comes in morning and evening, and they live in poverty often. You know, it has an economic effect when you have severe ME/CFS. So you need to know all that before you go to visit somebody or before you invite them to come to see you. So what have we learned? That it's a real challenge to interact with people with ME. Even the mildly affected, it's quite a challenge because there's to date no biomarker and no effective treatment. So these people are very stigmatized. Loads of people in their lives have said to them, oh, well, you're not really ill. I saw you once at such and such and you looked fine. And what they don't realize is that it took them a month to get over that visit to the cinema or visit to a wedding. And it necessitates a lot of wisdom and compassion from the person actually interacting with the person with ME/CFS. You really do need to learn quite a lot about the disease through reading, through talking to people, through listening to people with the illness. And you need to have endless patience. And the healthcare professional can feel pretty vulnerable because very often the patient knows almost as much about the disease as you do, and sometimes more. And sometimes they'll ask a question that's really pretty scientific, and you may or may not have the answer. So you can be very vulnerable. And you have to accept that sometimes you have to say, I don't know, I'll try and find out, is a really good answer. But be prepared to be challenged. And then there's a huge amount of expectation. Sometimes, and it may be different in the Netherlands, but often in England, they are cut off and ostracized by the health services. They've been told there's nothing much wrong with them, and so they stop going. So when you say you're coming to visit, it's a really big deal, and they've waited for your visit, and they're either spilling over with stuff that they want to tell you, or they shut down and they clam down, and you have to try and gently ease it out of them. And you can learn such a lot about that person when you visit them in their home by looking around. Ah, well done, what did you do? Magic. You can learn such a lot from the sort of signs. Yeah, there's a photo of them when they climbed Kilimanjaro, and now they're in a darkened room with earplugs in. And you can't even turn on the light to take blood. But you realise, you know, the person they were before the illness was so very, very different. So we found that any appointment should take place later in the morning, even for the mildly, moderately affected. And certainly, if they're severely affected, very late morning. They're time consuming. We allow 40 minutes to an hour, but sometimes that takes a lot longer. They are often cancelled. You have to be prepared for disappointment. People don't feel well on the day. The anticipation is sometimes overwhelming, and the appointments are cancelled, and you reschedule and you reschedule. And sometimes a 6-month follow-up appointment will happen a year and a half later, simply because you haven't been able to organise it with the patient successfully before then. And there may be a little bit of hostility, not so much from the person with ME/CFS, but maybe from their relatives, who are very protective of the person they're caring for. And as I say, you may feel challenged and impotent. There's very little advice you can offer. Your role as a researcher isn't to offer advice, but they're looking for something. And I think validation is the most important thing that you can offer. So these are some things that I learned as I went round, and I think they're very interesting comments from people. You can see the columns in the right. These are the people with severe ME/CFS who had those symptoms, and then the percentage with severe symptoms. And these are just things that people told me. When I wake up, often in the late morning, I feel no more rested than I did at the end of the day before. Everything is an effort, no matter how long the time of sleep. And when I look at the list of tests that you want to do on people, and this was a father, if my daughter cleans her teeth herself, that's it for a week. She can't do anything else. And one participant who was trying to do a questionnaire said to me, reading is like trying to listen to the radio. When there's so much interference, you can only hear the odd word. And that's what it's like when you put a questionnaire in front of them, even if it's online. And when someone visits, I have to choose. I can either eat a biscuit and have a cup of tea or listen and respond, but I can't do both. So it's kind of really important that when you're going through the process, that you do it very methodically and calmly and taking your time, and you don't bombard people with too much information at once. I'm so sorry, I know you just asked me to do something, but I can't remember what it was. Maybe I asked them to go and give me a urine sample. Would you mind shining a light on my arm to take blood away from my eyes? I just can't tolerate any light. One participant's parent said to me, please don't come in clothes that you've just washed, because the scent of the washing products will make my daughter ill for a week. So please don't do that. Come in something that you've already worn. And I never, ever wear any kind of scent or scented hand cream or anything like that when I see participants. And then a participant once said to me, I had to write that down straight away, or I forget what you said, and I forget I need to write it down. So you have to be very gentle. I heard someone saying if after 3 months no one's filled in the questionnaire, whoa, 3 months is quite good for a really severely affected participant. What we do tell them is, remember how you were the day I came. And sometimes I grasp at words, feeling like a toddler learning to speak all over again. So you need compassion. It's critical to guiding all your interactions with people with ME. And it's evident in all the practical tasks, the way you approach someone, the way you touch someone. You know, people will really judge it if you go to them and touch them very brusquely, as you might in a normal outpatient clinic. It has to be done really gently. Timing phone calls and visits thoughtfully. In fact, I found email much better than phone calls, because the participant can open an email at their own, in their own time frame, and using that tone of voice and physical contact that's appropriate, allowing time for questions and responses. That's critical. That's fine. It's about 5 minutes. So care. We're not there to care, but we do have to care and be careful. And one of the most important things is to try not to cause deterioration of the patient's condition. And this was really important in COVID. So we had to go to our ethics committee and find out how I was going to visit participants when the COVID epidemic was on. Visit, that looks as if it's Dutch. Anyway, they suggested that I went in full PPE, which I did, mask, something over my head, and we did the consultations in the garden of participants who were happy to see me. So it was we had some quite exciting photos. I prioritized the research agenda according to what I think the patient is going to be able to do. So standing, sitting blood pressure is often academic with someone who's severely affected. It's just something that has to go. But there are other things that they might be able to do. Avoiding sensory overload we've talked about, and being careful not to introduce infection. So very often when you go into somebody's house, they'll give you overshoes to put over your stocking feet. I always take off my shoes. I'm very careful about where the suitcase has been. I have a suitcase with all the equipment before I go in there. And if I myself was unwell, I would never go. And recently I always take a COVID test before I go and visit. And I was talking about the individual waiting with so much to say or finding it difficult to actually answer any questions at all because of the anticipation of your visit. Listening. You really do have to listen because it's in the little things that you hear the truth of the situation and the truth of what they're experiencing. Taking time to hear and interpret, you know, when somebody tells you something, you might be able to relate it to something you've read or something you knew about, and you might be able to guide them a little bit. And seeking clues about the former person. People particularly with severe ME/CFS often redefine themselves completely. And validating the individual. The very least you can say is how much they will have progressed the study with their participation. Some of the participants I've been to visit 5 or 6 times, and many of them I know all about their families, I know about their pets, I know about what's happening in their lives, and my new German research fellow really doesn't get this at all at the moment, although she's beginning to. Why do I want to know the pet went to the vet yesterday? But you just do, and you just you become very, very important. Without a dependency, but if you have the time, then you can react. Ongoing commitment may require communication between visits, endless patience with scheduling issues we talked about. And sometimes you have to listen to participants telling you that they're embracing the most extraordinary treatments that are totally unscientific. And as researchers, it's not our place to judge, but it's quite interesting to hear what happens as time goes on with these treatments. So I'd like to thank all the people with ME/CFS who've been involved in our study, particularly the ones who welcomed me into their homes, and they shared their challenges, their joys, their dreams, and their losses. And I think it's been a real privilege for all of us. And that's the team as we are at the moment. And those are our funders over the years. And Eliana failed to say that she and Louis started with £100,000 20 years ago. So your millions, we'll be expecting great things.
Yes, I knew you would scare me. Thank you very much. This is very informative, obviously, and I'm very grateful that you came over and that you want to be collaborative partners for us and help us out getting this thing started, because we realize it's a big challenge, but somebody got to do it, and hopefully we're going to do it. Well, thank you very much. It's now a time for a coffee break, and after that we will introduce our project as we had in mind. We started out with the Biobank and try to make it a bit sexy, and then we go to the individual studies, 6 of them. Welcome everybody. Can you hear me all well? Yeah. So I want to thank again the keynote speakers of today for their beautiful introduction, and also their work has been guiding the way. They've always been very kind and very helpful with providing advice, and they were involved in writing the application. So they're really part of the team. I really appreciate more than appreciate. I extremely value their input. They're extremely helpful to us. So initially I had a 5-minute introduction, and then would be the keynote. So I have my 5-minute introduction, and you will notice that because to avoid repetition, I will sometimes skip through slides a little bit faster. So my name is Bosch, and I'm the PI of the NMCB, and the NMCB is a national infrastructure for research into ME/CVS, and it involves Biobank and a Cohort affiliate attached to it, 6 research projects, 3 main patient organizations that are part of the board, of the executive board, and numerous partners throughout. So all 7 UMCs are involved, 3 universities, 2 3 patient organizations, 3 research organizations, including the RVM, the KNW, and the GGD locally. So it's quite large. You have seen, you now know what ME/CVS is. So these are maybe not the key symptoms, but several of them. And we don't know what the cause is. Some people report infection or physical trauma or medical trauma as a trigger. Then it started after that. We don't know exactly why. And some it has an insidious start, spontaneous, unknown trigger. So the prevalence rates, the estimates vary tremendously, but prevalence rate pre-COVID were around between 0.1 and 2.8%. So if you look up, then the rough estimate, the median will be around 0.8, which you will get if the diagnostic criteria vary between studies. And the prevalence rates post-COVID, we don't know for sure, but it's unknown, but probably 2 to 3-fold increase. That's simply because 75% of the general population is seropositive because of an infection with COVID, and say on average 8% of those infected have a half year later still post-COVID symptoms, or a year later, 18 months later. This is approximately the percentage. And of those, 25 to 60%, again see that the estimates vary tremendously, have fulfill the criteria for ME/CVS. And so if you do have a very conservative estimate, you would say that the population has at least doubled. And so this is the situation for those patients. Amongst other things, patient experience debilitating physical symptoms with little hope for spontaneous recovery. Diagnosis relies on clinical judgment. There's no biomarker. Treatment is symptomatic. And it comes all with substantial personal and societal costs. So you have stigmatization, social isolation, was just explained to you, high unemployment rates, and so forth and so on. And so there was the research landscape in the Netherlands was not very conducive to research in this area. And there was very little investment in biomedical research into ME/CVS. The existing research that was there was scattered with limited international collaboration, or let alone national collaboration. It lacked an infrastructure, social infrastructure, researchers that know each other and work with each other. That was limited, but also a physical infrastructure. So a biobank, research facilities that you could use for that type of research. And generally, the poor funding prospects also make researchers shy away. If you can go do your PhD in ME/CVS or another disease, well, you just select where there's a future for you, right? So that creates a self-perpetuating situation. And in that light, and the history has been explained to some of you already earlier today. So this is for some of you, there will be a repetition. Groep Den Haag submitted a citizens initiative to petition the parliament, and that they asked the National Health Council to give an advice, an advisory. And the advice of the National Health Council was to invest in a long-term and substantive biomedical research program to ME/CVS. AutonoME, that was then an order was given, or I say that an assignment was given to AutonoME to develop a biomedical research agenda, and it was approved by the parliament, and who allocated a budget of 28.5 million. And then in April 22, we submitted the research proposal. I want to 2 slides back. That's what slide I showed you, some of you this morning. I haven't showed you here, but after this slide, I showed another slide showing the symptoms, most prevalent symptoms in those suffering from post-COVID. And it's almost a carbon copy. It's very similar in the large proportions of patients that we call post-COVID have the same constellation of symptoms. And that's something I wanted to emphasize. I regret that I missed that slide. And there's reasons that I want to emphasize that, but I'll come to that later. So the in Dutch here, but the aims of that program was to improve diagnosis and identify causes of ME/CVS and improve treatment. And so we submitted an application, and it was awarded. So it was awarded where 6 research projects, which will be doing presentation after I did mine, and an ME/CVS cohort Biobank. So 6 biomedical research projects, a study cohort with patients was funded, a neurobiobank uniquely, and a biomaterials biobank. And this is what very large consortium that is nationwide. So and so this is text from the research agenda. This is actually the front page of the research agenda, and the task was to initiate a substantive long-term biomedical research program to ME/CVS. That was the goal of the research. So now I'm going already into what that program wanted to achieve, and very central in what the I must say the patients wanted to see, because the patients were very instrumental in developing that research agenda. It was not designed by the National Health Council, as maybe my prior slides were suggested. They just issued the assignment. It was really developed in strong collaboration, largely by patients. And so what they wanted to see is that patients were followed over several years, and was a large cohort. I mean, typical studies in this field are underpowered, small scale, and that creates a lot of irreproducible research findings. They want to have a good representation of the various target groups, so young, old, disease burden, those severely ill who often are missing in research have to be involved. Good logistics, so people that cannot come to the hospital will be visited at home by trained nurses and will be seen by experienced clinicians. It has to be collaborative, and I showed you that we have done that. So hospitals, universities have to collaborate as broadly as possible, and various disciplines have to be involved, not just immunology, not just cardiology, but a mix of disciplines, because it's a multi-system disease. And to use clinical study populations, use the infrastructure that's already there. So, for example, we also recruit patients from other post-infectious cohorts like Lyme disease or post-COVID, Q fever. And so we use what's already there and add to that ME/CVS questionnaires and tests and measurements. And last thing, they want a high standardization and collection of storage, open science policies, so available data and fair data use. And I will not go into that, what fair means, but it means that essentially the data is accessible and available to other researchers and the general public even. So, and they want to have a strong international collaboration, harmonization. So what we do here can be compared to what other researchers do around the world. So one problem in the field is that sometimes there are very promising findings, but other groups then cannot replicate it because they use other methods or other strategies or other sub-samples, and we want to avoid that. So we make sure that what we do is comparable to what other people do. And we want to make sure that there's a national, international collaboration. So we collaborate very closely with the UK ME/CVS Biobank and Open Medicine Institute and SolveME in training, for example, for nurses, how database is organized, what measures we do, how we harmonize our diagnostics and data collection procedures, and also nationally, we link our procedures to other post-infectious syndromes, cohorts in biobanks, such as Lyme, I already mentioned that, but also clinical cohorts, MS, multiple sclerosis biobank data. So we collaborate for that with the UMC, and we'll help out RIVM and Erasmus. And also we harmonized, there was a special request also by AutonoME that we harmonized with the Lifelines study, which is comparable to the UK Biobank, a large population cohort in the north of the Netherlands. And that's involved as well. So we submitted our grant. And if you later will ask, did you do this, did you do that? Everything we wrote down there is what we're going to do. This is part of the grants funded, is part of the program. So, and so the mission was to establish 4 things: a collaborative national research infrastructure that collects and secures high quality patient data, to test hypotheses that will lead to a sound mechanistic understanding of ME/CVS, and to see that in translation into rational diagnosis and treatment. And yeah. Oh, dat gaan we niet redden. I want to, for the general public here, I want to explain what is a biobank and why do we need it, because it's probably the least sexy aspect of the whole. Everybody's interested in the research and what fantastic findings will come out of that, and for obvious reasons, clearly. And so biobank, it's a bit boring. And so I want to explain why we need it. And so, well, first of all, what's a cohort? A cohort is there's a group of patients or a group of people. And what we use it to understand the causes, the characteristics, the consequences of disease by comparing groups and follow them over time. So you have patients and then you want to compare them to controls, as we call them, people without a disease, or people with another disease, and then compare what are the similarities and what are the differences. And that by that way, we can figure out what's going on with those patients. At least we hope so. But also within the patients we can compare, because we can compare patients with pain or patients without pain, or patients who started the disease with an infection or started their disease with a physical trauma. So that we can do. That's why we need to collect a cohort. And also it forms a registry of patients who wish to participate in treatment studies. So we have them in our database. We have them characterized really carefully, and then we can call them up and say, well, we have a possible treatment. Are you interested in participating in that study? And because we have all the details of those patients, very good study subjects, and if they say yes, then we have that registry ready, and we have all the materials biobanked. So what is a biobank? Well, that's just like you put money on the bank. You can also put biological samples on the bank. It's called the safe and secure, the long-term secure storage of biomaterials and patient information. And so what we collect is blood, for example, plasma and serum, for which you can measure things that have to do with infection, inflammation, and metabolism. Cells, which have to do with things with DNA, mitochondria, and immune tests. Maybe you heard of that. And fecal samples. So that's shit to say the least. And we get the microbiome out of it. Urine, saliva, EEG, fMRIs to measure brain functions. And so why do we need a biobank and a cohort? Why do we need it? Well, first of all, it makes research much faster. It makes research much cheaper. It makes research much better. And it makes it easy to collaborate. So you create research with much more impact. And I'll show you that. Let's assume you're a researcher. You have a fantastic idea. And so what do? You write it up as a research proposal, and that's being evaluated by the committee. Well, already around about 80% stops there. Doesn't get any money for it. And this process alone can take half a year to a year. So then you get the money. Let's assume you're the lucky 20%. Then you have to go for ethical approval, legal approval. That can take months, sometimes even up to a year. So then you finally can get started with your study. You start recruiting your patients and the data collection. So painstakingly you get every patient in. Now you just heard in the last lecture how much time and effort it costs. So finally, 1 or 2 years later, and 150,000 to 700,000 euros poorer, you can get started with your data analysis. First of all, you have to, because money is scarce, you have to work with small samples. You can only collect it. That's what's essential. You do it in your own way, not necessarily the comparison with other studies in mind, and you can be less selective. You're happy with everybody you can get. Now assume you get another idea. There's a biobank. You say, well, can I have your samples? I want to have samples of those patients who have pain. I want to compare them without any pain. Are there any differences? Sure, you can get them within 2 to 3 months or 2 to 6 months. You get your samples. It costs you a fraction of the money, like 1%, and 50% of the time. And then you can get started with your analysis, which is already expensive enough. So you see that a biobank is an enormous accelerator of research, makes it better. You can also afford to do larger samples, work with richer data, more standardized and more focused selection. So what we do here is the NMCB cohort. We have a timeline and a design. What we do is we're now around here. We validate our methods and we start recruiting. We hope to do that starting in May. And we organize a clinical follow-up. And then the first 4 years, we do basic fundamental research, laboratory-based research, and then we hope to find answers that we can use in the clinic, either for diagnostics or for treatment. That's the hope. And we store our samples, all biological materials, for other researchers as well for the next 20 years. And so we collect data from 750 ME/CVH patients who fulfill the various case criteria, and 25% are bed and housebound. And we compare it to healthy controls, as just explained, and 500 clinical controls. Many of them have post-infectious syndromes. And we also have a cohort with young adults. And now recently we got funding to also include long COVID patients. And so we can compare them. Long COVID patients will be the controls for ME/CVS, and ME/CVS patients will be the control for long COVID. And maybe we find out that part of them is the same disease. Well, we collect data online with questionnaires and cognitive tests, and we collect data online on location. If you can't come to the hospital visit, you get a visit at home where we collect samples and assessment. Do assessments and collect samples, blood, for example. Or there will be a hospital visit, and that's probably only available to a part of the participants, where we can do a scan or do more complicated and more involving measures for those who are willing to participate and can participate in that type of more intensive research. And so this is for Jörg. You can quickly say your bit, last 3 slides.
Yes, thank you, Jos. Jos,
you're the next one.
5 minutes to explain a bit the material collection we are going to do. I'm the head of the Central Biobank here at Amsterdam UMC, and I will help building the biobank collection with the core team, with Paula Metzler, closely involved in that. And now we can, the next slide. Just a few goals that we have with this National Biobank for ME/CFS. To the left, you see the researcher perspective. I think it's very key to go for the highest quality of materials. So this is evident. We want to build a large cohort of the patients and the different control groups. We will provide material to the 6 sub-projects or sub-studies of this consortium, but also to studies that will start in the future, and to studies abroad, and to researchers from other countries. So this is really a very broad purpose for the biobank. Extensive records of sampling of samples and the processing and harmonization with international biobank standards, and also with national biobank standards that we developed with academic hospitals in the Netherlands. From the patient perspective, we try to reduce the burden of the material collection as far as we can. We have heard the great talk today about how this has been organized in the UK and is going there. And I think we will try to learn as much as we can from there. We will include severely ill people by visiting them at home. And for those of you who are not fully used to think about laboratory processes and biomaterials, most of the materials that we will use will come from the blood that we collect from the patients. Here you see the blood, the tube where blood has been collected. An anticoagulant is added, then the blood is centrifuged, and then you get a fractionation of the blood. And I don't know whether it works, but you see then here in the upper part, the plasma fraction. This is basically water with minerals, with proteins, which will be aliquoted and stored. Then we have here the red blood cells in the lower part. These are the erythrocytes. We have not really plans with these cells so far. And then there is here a small phase in between, in which we have the white cells. These are the monocytes, T cells, B cells, and K cells. And we already saw that there is quite some interest in these cells. So we will store and freeze these cells as living cells so that they can be stored and cultured in the future. But we also use these white cells to get DNA and RNA for genomics and transcriptomic profiling the participants of the study. Just two pictures of the biobank. Here you see the many aliquots that we go to store at -70 degrees in our ultra low temperature freezers that we have. And an overview of the materials, we will collect 120 milliliter blood. This seems to us as a responsible amount, and we will generate roughly 50 aliquots. This is really a very, very rich biobank that we have with many opportunities for doing research later on. And I will not go through all these details. We built this table together with the projects that we now have, the 6 projects, but we also thought about how to secure research in the future. So it is much broader than the needs of the current projects that we have. Just a few more details, and I think this was my part. Thank you.
Thank you. Yeah, so
I don't at all think that biobanking is boring.
sorry, Jörg, I should never said that, but you did remember it. We also do physical assessment, not only stuff from the blood. We a number of physical measurements. This will be recorded and you can look over it. I don't want to take much more time. And we publish our protocols online as well, so you can look it all up. Our aim is to be as transparent as possible about what we do. And the last part, we also do EEG, and MRI, and then you're going to say the last slide about that.
Yeah, thank you, Jos. I think even a bit more sectionary than the biobank are the MRI images we also going to acquire with this biobank. And also happy that Jonas pointed out the neurological aspects of ME/CVS, which are very important, I think, to further investigate and to biobank, and that's particularly our goal. And for those not really familiar with MRI, it's a medical imaging technique. It's actually safe. It's not invasive. It uses a giant magnetic field, and with that you can pulse radio frequencies, and you can align hydrogen atoms, and you can just investigate soft tissue. And the brain, and actually the entire body, is for a large part built with hydrogen atoms, and you can easily investigate all kinds of soft tissues in the brain with MRI. And for this biobank, we have still a bit in the drafting phase of the MRI protocol, but it for sure lasts approximately 45 minutes. And we're going to scan on several locations throughout the country, which will be Amsterdam, Nijmegen, and Leiden. And actually, I'm on behalf here of Guido van Wingen, but also on behalf of a larger neuroimaging expert team who are still thinking about how can we use this 45 minutes to get the best out of our scanning time for ME/CVS patients. And of course, we were also looking upon what's currently happening in the world, for example, in the UK and in Germany, and how we can make use of and align or inspire ourselves with the MRI images will be acquired in those countries. Next slide. Oh, sorry, there was also an example images for those not really familiar with it. Actually, so that we can measure various aspects. We're going to look at the brain function, at the brain and the brain structure, and more importantly, we can also use quantitative MRI, which is more the innovative part the last few years, is you can really quantify signals of the brain, which are easily comparable between hospitals, between sites, and also with other biobanks, for example. And this may be a bit detailed, but just to point out that, we're going to look at, for example, the structure of the brain, the cortical thickness, the gray matter, the white matter. You can see that in the top image. You can look at brain communication, so you can just calculate how the communication is between each color of the partialization you see of the brain in the middle image. And you can also look at perfusion, so we can look at a wide range of characteristics of the brain. So I'm very hopeful that will help the biobank.
Thank you very much. Sanne Vervaai, so thank you very much. And this is Jörg Hamann, head of the Biobank. Thank you very much. And also, Jörg, thank you very much for your support, because it would have not been possible to get it all started without your expertise on board. Yeah. And the next one is Ruud. Yeah. Now we're going to the research projects.
With you? Yes. So, my name is Ruud Raijmakers. I am one of the researchers involved in one of the sub-projects, which is basically a biomedical investigation of both ME/CFS, but also various post-acute infectious syndromes. This is our project team. The research team, as you can see, is almost as widely dispersed as the entire NMCB, but it's mainly focused in the Radboud UMC in Nijmegen, where we're going to conduct the analyses. Our team has a lot of patient involvement as well, all of whom I would very much like to thank. We've had quite some productive meetings already, so I'm looking forward to a very fruitful collaboration in the future as well. Just a little background on the post-acute infectious syndromes. Basically, there are disabling symptoms that can arise following infections lasting over 6 months, following around 5 to 30% of infections. And there's loads of infections that can actually do this. There's a few notorious ones like EBV, like infectious mononucleosis, and also now COVID-19, Lyme disease, Q fever, and these are the ones we are actually going to be focusing on in our project as well. But the list goes on, and as was previously stated by Professor Bergquist, that ME/CFS is often precipitated by an infectious insult. So, and when you look at the ME/CFS definition over the years, it's changed tremendously since it was first described in the 1800s. But as you can see in some of these names, they all suggest that there is an infectious component going on here. I just jotted a few ones down, like brucellosis, polio, post-viral, candida, you name it, it's been associated with ME/CFS in the past. So, and what we are really interested in investigating now is, are these post-infectious syndromes and ME/CFS actually different, or are they the same in the pathophysiological basis? So we have a few steps we want to go through. Of course, we're going to make use of the structure of the biobank, and in the biobank, as Jos said, we are going to include ME/CFS patients, but also various clinical controls. So the post-acute infectious syndrome patients like long COVID, Q fever fatigue syndrome, and post-treatment Lyme disease syndrome. As with the biobank and such a large project, it probably takes a while for all these patients to get included. So we are going to make a head start with some data we have. So we are going to make a head start in a prospective cohort, which is the Lyme prospect study, in which patients were included at the time of a Lyme infection and were then followed up for around a year now, which gives us some really interesting data. So we can basically, we have measurements, we have blood plasma at the time of infection and 6 weeks thereafter. And we can sort of differentiate those who develop complaints and those who recovered nicely from the complaints. And what we plan to do actually is we plan to do a analysis of the plasma, looking for inflammatory markers, but also a very large metabolic profile. And we're going to do this in point 2 here, after we've investigated the ME/CFS prevalence using questionnaires in this entire cohort. So that's something we can start on immediately, and it's something we are working on at this moment, actually. For the larger comparison of all the post-acute infectious syndromes with ME/CFS, we have submitted MTC document, which is pending for approval. So that's the current status of our project. We are still very much starting up. We do have some future plans as well. We are going to investigate the Lyme prospect cohort, especially now with the new long COVID goal. There is a lot of ask for additional investigation of the various post-infectious syndromes and ME/CFS. So we're going to try to make use of that and try to expand our analyses basically in this cohort. We also trying to investigate the kynurenine pathway, which has been recently published by a group here in the Amsterdam UMC. So this is definitely a living project as well. We are trying to expand with analyses as we go, and of course, if we find interesting findings, we try to further differentiate and see if we can finally work towards finding a biomarker and possibly also a target for treatment in the future. So this is basically a general outline of a project. Like I said, we're still starting. So if you have questions and especially suggestions, please let me know. Thank you.
Thank you for all of those excellent presentations. I guess I have a general question. I'm with the post-COVID patient organization, by the way, and I guess I have a general question about the biobank. It was mentioned earlier that young adults are included, and I was wondering why kids weren't mentioned and if there are any plans to include them.
Yes, definitely. Niels can give me the answer, but I will do if I present, because I will introduce the children cohort. Yeah.
And I think you are the next presenter, right? Any other?
Peter Dean. I was wondering, let's say, because PEM is considered to be the hallmark of ME/CFS, I also intended to do some experiments in which you're going to do exercise tests, brain or bicycle or any kind of those kind of things.
For our project, no. We are just going to do cross-sectional analysis across these various syndromes, plus an investigation of the longitudinal cohort, of course. I know that there are other projects that are focusing on that, actually. Yeah.
Okay, thank you.
Thanks. My name is Anske van der Bom. It was mentioned that you do have controls like healthy persons and also persons who recovered nicer. So, but for this project, you only choose the ones who have recovered and not the healthy controls. Can you explain why you do that?
Yeah, so basically, for the cohort, the Lyme cohort, we have data on everyone that got a Lyme infection at the beginning, and then we can make a differentiation in those who recover, those who keep remain having complaints. So that's what we want to do. But for the larger comparison of various post-infectious syndromes, we intend to include both recovered patients and healthy controls.
But why? And why did you not choose here also the healthy controls?
Well, because they're not incorporated in the Lyme prospect study initially, so we have to do with the data that we have. For the larger biobank data, we're going to include the health controls as a control for the ME/CFS patients.
Okay, thank you very much.
Thank you, Ruud. You mentioned mononucleosis, that's Epstein-Barr virus. Are you going to include all the human herpes viruses? Because a lot of patients have the trigger cytomegalovirus. Are you researching all the human herpes viruses?
I don't think we are going to do serology for all the human herpes viruses in the inclusion, because then we have to do that in the inclusion in the general database and biobank, but I don't think that's included. There are some serological investigations, for example, for the Q fever and the Lyme study that we are including, but not for the herpes viruses. Sorry.
I have maybe a research-related question. So it sounds like you have a very large groups of people with many biomarkers and many aspects. How are you, from a research perspective, trying to ensure you get to results? I mean, that's the worry, right? I mean, there's so much variety in all these patients groups. How are you trying to capture the result?
Yeah, that's a good question, because a lot of it is actually a basic comparison of the various groups. From these comparisons, we try to identify targetable biomarkers, targetable treatment options. Actually, if you do large omics data, then hopefully you will obtain between 5 or 8 biomarkers, for example. We can further investigate and test their value for perhaps a prediction for developing ME/CFS. That's basically what we try to do here.
Yeah, I think the risk is you don't get anything clearly.
Yeah. I get where you're coming from. But it's basically the setup of this study was make a comparison. How do all these different disease types, how do they relate to each other? Are they actually different due to the different infectious insults, or are they basically the same? And can we sort of bundle our strength, our forces, and try to look for a commonality together. Yeah.
I think the floor is to you, Niels.
All right, so we continue to the next project. Well, this works as far. Too loud. So I'll be talking about a project that we called EnergiseME, and it will be about the links between autoimmunity and derangement in immune cell metabolism and function in ME/CVS. I'm here just as one of the representatives. This is also just to highlight the different members at the local team that will be involved in this project anyhow. So I'm just representing a bigger group, and of course, we're also collaborating with Jeroen Dunnen because we're tightly linked to his project. He will tell more about it next to it. But also last week, I had a fantastic conversation already with the patient representatives. So next time, their pictures will be also on. So it's a big team. So what are we going to do? Well, first of all, as I already said, sexy research questions need sexy cohorts, right? Now, good cohorts and a good question need to go together. In general, we always think about adults. And as said, there will be a nice, beautiful adult cohort. In general, in medicine, I think, if I grow it a bit bigger, diseases are often a bit more forgotten in pediatric population, cohort-wise, trial-wise. So what we also hope to do, what we will going to do, is also really build a pediatric cohort. Why? Because, well, if you only look in the Netherlands alone, there's more than 20,000 children with ME/CVS, prevalence numbers. And again, what I really want to highlight, the current dogma is still children are adults, but smaller. No, that's not the case. And I think by building a really good cohort, we actually can test this, whether biomedically ME/CVS is the same in pediatric population versus the adult. What are we going to do? We will build a cohort of 160 patients and controls, going as much as with the same questionnaires, but they're adapted to children, of course. We will also have tests and collect biological samples, all with the limitation that they are those smaller, so we have a little bit less blood, but within the limits what is also possible for the patients. So that's one important aspect. So what are we then going to do with these pediatric samples, but also the adult? And that I basically what we're trying to do is couple 4 topics that actually Jonas already has mentioned in it, because we know there's some signs of autoimmunity, immune derangements, metabolic deficits, and neurological signs. So what we're trying to do is basically couple them to a certain level to each other, because we will test whether autoantibodies, what Jeroen will be talking more about, can actually cause metabolic defects in immune cells, specifically monocytes, and whether these changes affect the behavior of these cells to communicate with cells from the nervous system, neurons, and whether that can lead either to the fact that these neurons respond differently to output from immune cells, or vice versa, whether immune cells respond differently to output from sensory or from neurons. Sounds fun. How are you going to do that? Again, we go back to the cohort. And what we will be doing, we'll be using ME and controls, adult and pediatric. And first, what we hope to do is at least try to create some subgroups. Apologies for the Dutch, I see, by looking at the blood and doing a very proteomic analysis, as already has been mentioned, including with all the patient-reported outcomes, whether we can make subgroups. So also kind of deal with the heterogeneity within the big, large population. And based on that, data will speak. We will create 2 or 4 groups, and we will do subsequent tests with samples of these patients. And the first important aspect, what we're trying to do, is really look, what are these metabolic disturbances that are there in the patient groups and specifically in these subgroups? We'll use mass spectrometry to really look at the metabolites, and this is just an example with a smaller pediatric cohort, what we have done, where we see that some metabolites are, for example, reduced in ME and QVS patients. We will sequence cells, but also specifically look at the energy machines, the mitochondria in these immune cells, to really see what is going different. And specifically what we also do go with the fancy word, fluxomics, is basically how does a cell specifically deal with metabolites within the cell, to really understand if they maybe deal differently with these metabolites compared to healthy controls. Okay, if you do that, then you have some things that are changed in patient, but what we want to do, we want to understand how does that then affect the function, for example, of an immune cell. What does it do if we recreate these metabolic derangement in these cells on their behavior? And how does that affect how these cells are going to communicate with nervous cells? And vice versa, how are these cells responding differently to neurons? So with that, we try to create a bit more causality of the differences that we find to the function of cells. And finally, because that still doesn't really explain, if you find these differences or the interactions, how does that then explain potential symptoms in patients? And what we hope to do is that if we find specific alterations, metabolic alterations in cells, that we recreate these in immune cells in mice and perform various cognitive and other behavioral assays in these mice to see whether they show similar kind of symptoms that are ME-like symptoms. Of course, they're mice that are similar, to kind of see if there's some causality to these changes that we'll see. And that is in a nutshell what we hope to do the upcoming 4 years. A lot of thanks also to Jos getting us all together, because that's what is the most important, getting together to get things done. Thanks. Questions?
We have questions for Niels. Yes.
Are you looking for specific audience bodies?
I think we will get excellent topics for the next.
Okay, then I'll keep it in my pocket. Thank you very much. Niels, how are research is being done abroad, being included in yours?
Very good question. I think that was supposed to can you hear me? Yeah. No, I think we really have to integrate. I think we already had an excellent talk this morning where there's also a lot of metabolic tests that have been done. So I think we have to incorporate that, especially if we also want to compare, because I don't think this has really been done in the pediatric cohort, so we can directly compare, are there similarities or not? So we have been incorporating a lot of international parties as well, so that we can discuss and that we can really discuss data, because ultimately it's about sharing the data to really make most sense of it as well. Right? Because every set of data will probably create more questions than we had originally. But I think by doing that together, I think we can make the most of it, especially with these large data sets, because they are complex.
Yeah. Now, just a small question, Niels.
Yeah.
Where are these neurons situated? Which are
So
target?
now it's a good point. So my lab originally is really focusing on the peripheral sensory system. However, we will be trying to, I'm saying a lot of trying. We also, for the sensory neurons, we have them up and running, IPC-derived neurons, but we can also try to create cortical-like neurons, but there we will interact with other parties that have more experience with that. But we primarily focus also on the peripheral sensory neurons, in particular also in the pediatric cohorts. For example, we're going to do pain assessments that we're very experienced in, so we can couple that hopefully directly also.
Which cell types?
Oh, sorry, in the monocytes, we're particularly going to focus, because also in the exactly, and I think from our pain work, we do know that, for example, monocytes communicate with sensory neurons by, for example, donating their mitochondria. So there are some interactions, and we want to also see whether this is, for example, the case in ME.
Niels, I would like to ask another question. It's more about the cohort, because you look at pediatric cohort in this case. I was wondering, let's say, are particular features of ME/CVS more pronounced in the pediatric cohort compared to the adult cohort? Because let's say I know the study from Chicago group who figured out that in a prospective study that, for example, the students who were starting to do this study had IBS, intestinal bowel syndrome, mainly as a cause to develop ME/CVS following mononucleosis.
So if I'm going to answer that question, I'm probably going to not correctly answer that. And that's why I'm also highly dependent. I'm so glad that also Sanne Nijhoff is also participating with the cohort. She is the pediatrician.
Okay.
I think she's online. I don't know if there's, she can answer that. But as far as I do, there are some differences. But I don't dare to say which particular ones there are. And maybe there are, I know there's a lot of experienced people here that can even indicate that. But I find it, as a scientist, a bit tricky now to answer something that I'm not 100% sure about.
Thanks.
Go to the next.
presentation. Jeroen de Dunnen.
And that's me, yes, great. First of all, great to be here and great to see so many of you here today. Faces of patients, patient representative I've only seen online before. Scientists, every coffee break that we have. I think I've made in the coffee break just already 5 new research proposals. It's really, these meetings are really crucial, I think, to get this going. I'm the PI of AutonoME, which is a project to study autoimmunity as a potential cause of ME/CFS. I'm the PI, and I'm collaborating with many here in the audience, Niels, Eijkelkamp, Rob Wüst, Brent, Appelman, many others as well. What we're going to try to figure out is autoimmunity. It has already been mentioned a couple of times that there's substantial overlap between ME/CFS and long COVID. And I think that's a good thing because it can give us clues. I think right now long COVID has been studied more extensively than ME/CFS, while ME/CFS has been around for way, way longer. And it's something we can benefit from. This is the national newspaper in the Netherlands, front page, opening the Saturday morning newspaper with long COVID. And it's a 4-page document about the potential causes of long COVID. And they made a pie chart, given basically the 4 main hypotheses. It's chronic infection, vascular, neurological, and one of them was autoimmunity. And I think this is important because of the overlap of long COVID and ME/CFS. We can really benefit from the knowledge that is already there, and something we've also contributed to a little in the last few years as well. Because once you want to know what is going on in a disease, the first tendency that we have as scientists is to figure out what is different. And if you look carefully enough, you're going to find differences. But these differences, are they really causal to the disease, or are they just circumstantial? And I think that's really important. We have found many differences between healthy individuals and patients, but are they really contributing to the disease? And when we had this, when we wanted to study long COVID, one of the hypotheses was already autoimmunity right from the start. And Niels, Eijkelkamp, and Brent Appelman and me, we thought, okay, but if there's really would be a causal relationship between autoimmunity and, in this case, long COVID, then we should be able to do the following experiment. We should take blood from patients. If you're autoimmune, you have antibodies against, not against a virus or a bacterium, but against yourself. The antibodies are attacking your own body. They are in the blood. So if you would take blood from patients and you would take out these antibodies specifically, nothing else, leave the rest apart, just take the antibodies. You will inject them into another species. One of our favorite ones is a mouse. Then the mice should get sick as well, right? And we cannot give them questionnaires, but we can do behavioral tests, and we did many here. And we did this experiment, which could have gone wrong in 100 different ways. But the thing is, it was pretty successful. So we categorized patients into different categories, basically based on, well, it was a bit arbitrary, it was a bit quick and dirty, but there were different symptoms, of course, that we had. We categorized them in these different groups. We injected these antibodies into mice, and what we saw was the mice got symptoms. And I think this was a key starting point for us in this field of research that we did, because we proved that just the transfer of antibodies, IgG antibodies, can cause symptoms in these mice, which also differ depending on the patient where it is coming from. And I think this is a great starting point also for ME/CFS. And that's actually exactly what we're going to do in this AutonoME project. We have different key objectives, but the first one, of course, is can we pull off the same trick in ME/CFS? So can we take antibodies from these patients, inject them in a mouse, and see whether the mice also get the symptoms that we see in long COVID? And if so, what are they binding to? How are they causing disease? To what tissues do they bind, and to what proteins do they bind? How do they cause disease? One of the questions popping up here was how are you going to figure out what these autoantibodies would be binding to? We did a large screening, for example, for long COVID, because we have 20,000 genes. We have way over 20,000 proteins, of course, where you can all make antibodies against. So we did a screening for 21,000 antigens, just checking everything. And then we found hits that were unique for, in this case, long COVID patients, but we want to do the same for ME/CFS. And then, of course, we want to know how are these antibodies making individuals sick? Because it's not just what antibodies recognize, but it's also, antibodies are these Y-shaped form. It's also the tail that critically determines if an antibody is pathogenic, if it makes people sick. Depending on the tail, an antibody can do nothing or can be extremely inflammatory. So that's what we need. The structure is something we want to figure out as well. And that is, in a nutshell, the AutonoME project focused on autoimmunity in NME CFS. Yes. Any questions?
Nice idea and nice experiments. Just a critical question. How much protein do you have to inject into a mouse to get this?
How much protein?
Yeah.
I mean,
so if you use
much,
the IgG, how much protein is getting into the mouse?
I think what we injected was 8 milligrams. Sorry?
6.4.
6.4. Yeah.
6.4 what? Milligrams.
Yes.
That's quite
Yes,
something.
It's much less, for example, in what they have done in the fibromyalgia field, where they have injected 3 or 4 times 8 mg.
Yeah, you don't have to report the sins of others.
It's a large dose, but also have to mention that it's only a very small fraction that is relevant, right? And if you do a very little bit, I think the relative amount is very little.
Yeah, I think that's a critical point, because in the end, the amount of human IgG in mice, the concentration in blood was lower than it is in humans, and we took total IgG, right? So it is.
Yeah, but that's as long as you accept that it's it's specific. What I'm pointing to is what's the non-specific component of the whole story.
The non-specific.
You take purified IgG, but if you would have taken, say, albumin at the same kind of concentration, or an alpha-1 antitrypsin, or any protein, would you see similar kind of things?
Yeah, in this case, that is of course speculation, but it is. We have hits now. We know what these antibodies are directed against, and we can actually inject them in a subsequent experiment to figure out what would be happening then. Of course, we did take along a control group, right? So we just purified IgG from controls, injected them, and nothing happened.
Okay.
So there is a difference between, in this case, long COVID and control.
And if you take, say, FABs or FC or to say isolated FCs.
Yeah, that we haven't done that, but that would be a great suggestion to see if the tail really matters. Absolutely, yeah.
Okay.
More experiments popping up. Very good.
Yes, just to follow up on that, have you considered if you could do immunohistochemistry to see what structures have been bound to from the human antibodies?
Yeah, so what we've done so far is stainings on the mice. So we took all these different tissues. There's huge background staining, probably because the IgG concentration is just very high and there's just non-specific sticking to these tissues. So it is tricky. I think we need to lower the amount of concentration and perhaps use just sections of, for example, brain or skeletal muscle, cardiac muscle with lower concentrations to see when the specific binding would occur between ME/CFS and controls. Yeah.
Someone on the left corner? Yeah.
Will you be using blood from the participants in the biobank?
Absolutely, yeah.
Have they given permission for animal experiments? Because we had an issue with this, and in fact, our steering group would not let us release blood for animal experiments because what they feared was 1 or 2 people who were already in the biobank here being notified of it, being up in arms, and then they're all connected through social networks. And so you would only have to have a couple of people who have felt really unhappy, and it might actually stimulate people asking for their samples to be withdrawn. So just a heads up.
Yeah, that's a really good point, actually. That's something I guess we can include in the like the questionnaire. Or?
Absolutely. Yeah, I think we should.
We haven't done so yet. Okay, so that's a really good remark. Thank you.
Nice studies that you have planned. Let's say the subtype of IgG can also vary during an infection, right? You have IgG 1, 2, 4, and so on. So do you also look into those kind of things, whether there is a change also, let's say, when you compare it to your controls? Because when somebody is not infected, the shift might not be as pronounced as in the affected or the patient.
Absolutely. So that's in key objective 3. We want to look at all the differences that you can have in antibodies. So that's isotype, subclass, allotype, and glycosylation.
Okay, great.
I'm Marjan Versnel from the Department of Immunology of the Erasmus MC, and I'm leading the IMMUNESTRATIFY project together with my co-PI Wim Dik. In our project, we aim to identify in ME/CFS patients homogeneous subgroups using immune signatures. And secondly, we want to investigate if trained immunity is playing a role in ME/CFS. ME/CFS is a very heterogeneous disease with differences in disease activity, symptoms, and chronic immune activation. Using immune signatures, we want to subclassify this patient group in homogeneous subgroups to come to personalized mechanism-based treatment in the future. An example of such an immune signature is the type 1 interferon signature. Type 1 interferon is a cytokine released when a person is infected by a virus, for instance. We found that in systemic autoimmune diseases, type 1 interferon is constantly activated. And type 1 interferon can activate all cells of the immune system. In this picture, you see how we are doing this. Type 1 interferon is rather difficult to measure reliable itself. Therefore, we measured these small lamps that are depicted here near the cell. Those are genes that are switched on when type 1 interferon is binding to a cell, and then we can measure the outcome. And as you can see in the graph here, these type 1 interferon, we can subclassify patients with systemic autoimmune diseases in interferon type 1 positive, interferon type 1 negative patients, which have the same level of type 1 interferon signature as the healthy controls. And in those diseases, there's a relationship between interferon type 1 positivity with disease activity and specific features. And subsequently, we developed an easy assay for this. An easy assay without needing to isolate these specific innate immune cells. This assay has been introduced in clinical practice in our diagnostic department in the Laboratory of Medical Immunology in the group of Wim Dik. And currently it's available for all clinicians upon request, and we get more than 100 requests per year. These are the immune signatures that we aim to identify in the patients. Those are all immune signatures that are found in diseases where fatigue is a symptom. We have the type 1 interferon signature, a serum fatigue signature from Sjögren's syndrome patients, a signature found in mood disorders, a recently published long COVID fatigue signature by Wim Dik and collaborators, and an in silico identified ME/CFS signature that Jos and Paula published. So in summary, we have all those immune signatures in the patient group, and we want to subclassify patients in homogeneous groups to come to an easy to measure immune aberration in those patients group. The next aim is to investigate trained immunity. Trained immunity or innate immune memory is an immune response of innate immune cells in the blood. Innate immune cells can respond after a first challenge with an immune response. But interestingly, when these cells are triggered with a secondary unrelated response, they have a higher response, as you can see in this picture. And this is normally a mechanism to protect against unrelated pathogens. We will study this mechanism in patients with ME/CFS. This trained immunity is also found in other human diseases, and it has been found, especially is characterized by enhanced cytokine expression, epigenetic and metabolic aberrations. Our approach will be the following. We will investigate ME/CFS blood cells for hyper-responsive phenotype when we stimulate the cells, and we are developing an in vitro model for trained immunity. We have already developed a model for using a monocytic cell line, and currently we are working with a microglia cell line. Microglia are the innate immune cells of the brain. Bart Humer, who is in the audience, is the PhD student that has been joined us in our project, and he already got some nice results together with Corine van Helden in my group. And what you can see in this graph, they first used these microglia cells in a training model, then they let the cells rest for a certain period, and then they re-stimulated the cells. And what you can appreciate here is that there's an increased response of this pro-inflammatory cytokine when you stimulate the cells, first with a trainer, interferon gamma in this case, and secondly, come back with another stimulus. The results of our project will be that we will develop a novel stratification tool based upon immune signatures, and it will ultimately lead to a specific treatment of the underlying immune aberrations. And the trained immunity research will give insight into the pathogenesis of the ME/CFS and ultimately also lead to new treatment options. This is our project team: Bart Humer, the student working on this project, Tobias de Vesch, another student, Corine van Helden, technician in my group, and Wim Dick. We collaborate, of course, with Jos Bos and his whole team in the NMCB Biobank. We have a collaboration with Leo Joosten, expert in trained immunity. We have a collaboration with pulmonology. And we have several advisors, Hemmo Drekshagen, working on immune signatures, Wan Fai and G in Newcastle, and Joris Vernooy from the Vermoeidheidskliniek. And luckily, we have a whole set of patients who recently joined our project as patient research partners, and we look forward to collaborate with them. Thank you very much for your attention.
Open to any questions? Yeah.
It's very interesting what you're going to do. I was wondering, are you also planning to do to see for the various post-infectious cohorts if these specific antigens can actually train the monocytes of healthy people? So if you take a spike antigen or a Q fever LPS?
Not yet, but okay. Ultimately, maybe.
Okay.
I will present to you our project Brain Changes in ME/CFS, with a focus on the stress and the immune system. With the goals, well, we would like to study brain changes, but we need human brain tissue for this. So we also will start a ME/CFS brain donor program in the Netherlands Brain Bank here in Amsterdam to get the tissue. So far as I know, there's no post-mortem human brain tissue available for people with ME/CFS. Although I just read, so we need a post-mortem human brain tissue for people with ME/CFS. And as far as I know, we don't have such tissue. Although I read that in Manchester, just an initiative was launched to collect such tissue. While also we now launch such an initiative. Well, it is for open access researchers worldwide, but we would like to study the stress axis and the immune system in it. This is our team. I saw that on the fourth row, 3 of them are present. I'm the director of the Netherlands Brain Bank and the leader of a neuroimmunology research group here in Amsterdam at the NIN. Jörg Hamann, well, you heard he's got a very interesting job in being the leader of the Central Biobank here in AMC. Paul Lucas, he's the leader of the neuroplasticity research group at the SILS, University of Amsterdam. Karel Scheepstra, who could not be here today, is a clinical psychiatrist, and Mignon de Goeie sitting there, she's a bureau manager of the Netherlands Brain Bank. The goal for the brain donor program is to get more, well, in fact, there is none yet, but more well-documented brain tissue, open access available for worldwide research, it's not only for our research project, to study molecular and cellular changes. The method will be to launch a donor program in order to register at minimum of 200 people with ME/CFS, we hope, within 4 years. So we, well, I think we will manage. And then realize, but that you never know, 50 autopsies in 4 to 8 years. Well, depends on the donors, of course, age and so forth. How will we do that? We do have experience in multiple sclerosis donor programs and donor programs for psychiatric diseases. We're quite successful. But we approach patient organizations and research cohorts, of course, because these patients are well documented. So we need all these data. We approach them, yeah, we don't know yet, via letter to ask whether they would participate or give lectures. We give articles. As soon as we launch the brain donor program, we will ask attention from the general public by a press release, possibly. There is a bit of an issue with the diagnostic criteria because we already had 25 people registered at the Netherlands Brain Bank with ME/CFS, but we are not, we don't agree in our team that I think we have 5, but then the clinicians in our team think that we have only 2 patients. So there are quite some comorbid diagnoses. So we have really make clear which will be included and who will not be included. The Netherlands Brain Bank, maybe some of you know it, maybe others not, but we in the Netherlands have a donor program during life. People sign up as brain donor as well as a next of kin. It has got 2 reasons. One is that the donorship is in harmony with the environment, but also for pragmatic reasons, and that is someone has to call us that when the donor dies. We are available day and night, and team will collect we will inform the autopsy team. A donor will be collected with using undertaker brought to Amsterdam, and the longest distance in the Netherlands is only 3 hours drive. Even from the islands, it's possible to get the donor quickly in Amsterdam. Team dissects the brain, and up to 200 regions will freeze it, fix it, or fresh, and then and it's disease specific. However, for ME, we don't know which regions to dissect. So I was hoping that today I would hear from you. Seems the hypothalamus and the insula should be dissected at least. But we will have an extensive dissection protocol, of course. It's open access for researchers worldwide. And because the distances are short, our post-mortem delay is only 6 hours. So we are known for it. It's because we are a small country that we can do this. We've got currently more than 5,000 donors registered, more than 5 autopsies done, and many people use it. These are the current registered donors. So I've got many control donors, very important, because you have to compare each region from a diseased donor with a donor that has not such a disease. Otherwise, you don't know what change is. We designed a logo according to our other logos. This is the logo of the Netherlands Brain Bank, the Netherlands Brain Institute, Netherlands Institute for Neuroscience, one of the institutes of the Netherlands Royal Academy of Arts and Sciences. So this is our logo for our donor program for psychiatric diseases. We were quite successful because we have now more donors registered with a psychiatric diagnosis as compared to those with a neurological diagnosis. So we can do it. It shows we can do it. This is our logo for our MS program, and this is what we decided will be the logo for our ME-CVS or CFS donor program. So what will we do for research? We will, of course, all these donors will have an extensive neuropathological analysis. So up to 30 regions will dissect it, and our neuropathologists will always, like all donors, analyze for all alterations. And the tissue will be available for researchers, but we will also do research with the tissue. And the goal is, the focus is on the stress and the immune system. Goal is to generate insight into changes in the brain of people with ME-CFS, CFS, and, well, of course, to possibly identify drug targets for first diagnosis, of course, second maybe intervention. And look at the HPA axis. We used brain tissue. Here's the hypothalamus with third ventricle. Here are the neurons in the periventricular nucleus that give rise to projections to the pituitary, and that will release ACTH. So we can see whether the HPA axis is activated at this level. Possibly we could have a look at more nuclei in the hypothalamus, because there also fatigue is known and there's other hormonal changes, but we will first focus on CRH neurons. Then we also are interested in immune responses, where the microglia are in an altered state. And we will explore also the mitochondria in nerve cells, so in neurons. And here you can see a nice picture of, in red, the mitochondria and nerve endings, so done with a STEP microscope. We also can have a look at the transcriptome and reactome of microglia, as well as lymphocytes from brain regions that are dissected at autopsy. This is fresh tissue. You can pull out cells using antibodies and iron beads, use a magnet to pull them out. And then you can do all kinds of things with it, like look at the RNA expression profile and use a flow cytometer for alterations. We already did this in other donor groups, like in depressive disorder, that was recently published. And there we had really amazing results that raised a lot of attention, draw a lot of attention. That is that in gray matter, cortical gray matter where neurons are situated, the number of genes in microglia cells was significantly reduced in MDD, whereas in the white matter they were not reduced. And it appeared that these microglia cells, in contrast to what everybody expected, were not immune activated, but inactivated. There were a few previous reports that had shown similar results. So all the ideas about immune activation in depression is not, in these brain donors, not correct. And the immune cells were, immune genes were downregulated, only in the gray matter where neurons was. So we thought, well, maybe the neurons inactivate microglia, and microglia could become themselves sort of depressed. And so we looked at molecules in the neurons that in fact control the activity of microglia, and indeed these, well, this is only in trend, but in the CD200 was significantly upregulated in depressed brain donors. So you see that this illustrates that the postmortem human brain tissue, if you select the groups well, you can find mechanisms that may relate to the disease. So that's it.
Thank you, Jonas. Thank you for the presentation. I just wonder if you have considered, because in the UK, when we discuss with the patient population that informed the Biobank for us, our main idea was to establish a brain bank. And one of the responses that we get from the patient population was that a concern about the potential spike on suicidal.
On potential?
a spike or
A spike?
yeah, in suicidal people. So
To donate ASAP. I don't know.
yes, I think that the idea, the concern was that people knowing about a brain bank, they could be suicidal to help other people. And they were concerned about that.
Yeah, well, we do have quite some donors that in the Netherlands we have legally assisted suicide and sent euthanasia. And in all donor groups with different diagnoses, it occurs and it increases. But the idea that signing up and accelerating somebody's death is never occurred to me. We had never any indication for it, but that would be terrible. Indeed, yeah. We should be careful. Yeah.
The patient population in the UK. So
yeah,
I'm just reporting.
Yeah, well, in the UK, there's a very professional brain bank, the MRC Brain Bank network. I'm involved in advising it, but I didn't occur that we should pay attention to that in our campaign. Yeah.
Yeah, thank you. A very important initiative also, I think. Although we have had concerns in Sweden with exactly what Eliana said, with because we don't have euthanasia in Sweden as it is now.
Yeah.
But another thing, have you set any strict rules on postmortem delay time or?
Well,
like that?
yeah, well, our postmortem delay is on average 6.5, max 10 hours.
Okay. Mm.
And that is what, we can do this because the distances are short.
Mm.
Yeah. So we are the fastest brain bank worldwide.
It remains a very sensitive topic, right? And
it makes me think. People consider it.
Have you had in mind to maybe consider same brain bank for post-COVID?
Yeah, well, we have already long COVID cases. We know that from the clinical data, but the focused donor program would indeed be interesting. But first, let us get experience now with a donor group with CFS. Yeah, but it would also be important and could be really quite similar concerning the possibility of a post-viral mechanism, also an MA. Then, yeah.
I saw one question coming up, the last one.
Yeah, is it possible? Imagine a patient, an older patient, ends up in the hospital and dies. Is it possible with regular donorship to indicate that a person could be part of the ME/CFS Biobank?
Well, yeah, I will already look at Neil. You really need to be registered as brain donor.
Yeah,
but if there's a sudden wish, then we can have a late registration. But in principle, if people are signed up to donate for transplantation, it's also always prioritized because you can save a life with it. And then it will be too late to take out the brain because we've got the sort of upper limit of 10 hours post-mortem delay. Sometimes it can be combined. You can be brain donor as well as donor for organ donation for organ transplantation.
So we're going now to the last talk of today. Rob Wüst, he's somewhat of a celebrity lately, together with Brent Alberman. It was a fantastic paper that just came out in Nature Communications. You couldn't have missed it, but he has more up his sleeve, as they say. So there you go.
Maybe is it still possible to hear in the back? Yeah, I see people nodding. Perfect. Well, thank you very much for staying late and hearing the last bit of the presentation. It's a bit lighter than Inge's presentation. So my project focuses particularly on skeletal muscle function and changes that we see with post-exertional malaise. So we all know, of course, that patients with long COVID and ME/CFS have lots of problems with general fatigue
And actually, the symptoms worsen with doing the lightest amount of exercise. So we really wanted to understand in this project what is happening. And we already started, as you can imagine. We started 2 years ago with the long COVID cohort, and essentially one of the goals of the next project is to extend this into patients with chronic fatigue syndrome, ME/CFS, and use the biobank as a starting point to collect more muscle biopsies from patients from severe to very minor disease severity. I forgot to add in the goals of the project. I see that a lot of other presenters before me did that, so I need to present that in the title slide. So the idea is to collect a large amount of data, amount of samples, and look at the skeletal muscle change that we see in the morphological changes, the metabolic changes that we see in the skeletal muscle, as well as the immunology that is happening. And we know that, for instance, exercise can affect the immune system, and how different is that involved in the patients with long COVID and as well as chronic fatigue syndrome. So because I'm the last presenter, I also thought that maybe, and we are also on our way, I thought maybe it's nice to present a little bit about what happened in the last 2 weeks. So this paper came out in Nature Communications, and people who worked on it are sitting in the back, Brent and also Braden. He's hiding in the very, very far corner. He's a PhD student on this particular project. And we specifically focused on skeletal muscle adaptations that occur after the induction of post-tertiary malaise with an exercise test. Now, you can see already from the title slide from the Nature Communication that has been viewed more than 150,000 times in 2 weeks' time, and has an odometric score, which maybe you don't really realize, but the odometric score is extremely high. Generally gets into the top. I expect it to be the top 10 papers of this year, viewed or talked about. So it has received a lot of attention with patients and also with media attention. And that has caused, of course, this paper to be covered in a lot of media outlets. All the major the Dutch journals or news articles spoke about it. We do see change in the tissue essentially. I mean, of course, we don't have the reason of the long COVID. We don't have the reason of the underlying molecular reason for the fatigue, but at least we see changes that are consistent with the symptoms that patients are experiencing. I need to say something this is maybe a little bit of a jokey end. I was on holiday when this all happened. We discussed it beforehand when the paper would come out, and I was attending a wedding in Chile. So I was super far away. Surprisingly, on the day of the wedding, also the Chilean newspaper was actually spending time and a whole paper in Spanish on this particular paper, and my name is even mentioned in the Chilean newspaper. So I was actually super excited, but we couldn't get the newspaper because it turned out to be more difficult than I expected. But it has caught a lot of attention. There will be more attention over the next weeks in particular US newspapers. So you will still see this coming up here and there for a few times. So I've had a few lessons. That's maybe something that I, at the end of the day, want to give back to you. I know long COVID, and as well as a result, also ME/CFS is actually becoming a very hot topic. Particularly patients, social media picks up these everything that relates to studies very well. I put a post on X or Twitter, has been viewed more than 1 million times worldwide. So yes, also there it got a little bit viral. I have to admit that hoge bomen vangen veel wind for the Dutch-speaking community, but also it raised a lot of attention, a lot of criticism too. People do try to have some negative comments here and there. anti-vaxxers, but also people who don't believe in the disease, for instance. You do get them, and also that means there is some discussion, of course, possible. We don't find a cure as well of the disease, so that makes it complicated. Internationally, I think everyone looks at this room, what happens here in the Netherlands on this topic. So there is a lot of attention right now on the long COVID as well as the ME/CFS research done in the Netherlands. I think that is very good news. We are not just a simple country. We do matter, I think, worldwide. We do know now that we need to really keep the press officers and patient organizations informed early onwards so that they can help us with the dissemination of results. And that would also be advisable for all your projects. And the last thing, of course, is that if you want to go on TV, don't go on holidays. But people can find you, and still people know where to find you. A little bit of background information about the post-exertional malaise, because that has been an important symptom for patients. And we get the general comment that isn't it just being inactive? Is inactivity not just the simple explanation for the change that you see? So that's not the case, and that's because we were able to compare our data with other data set that we've collected recently in collaboration with the ESA, the European Space Agency, where people have been inactive for more than 2 months. So we took muscle biopsies also from that cohort. That paper is also out just this year. And we actually compared the data with our long COVID cohort, and we currently, actually, as we speak, we're in the middle of the data collection of a group of 25 patients with ME/CFS. So we wanted to see whether the changes that are occurring in the skeletal muscle are simply due to being inactive. And I can assure you that that is not the case. It's not simply inactivity. And this maybe is a difficult slide but I'll slowly go through it. The exercise and the performance on a bike is similarly decreased with patients that are normal people that undergo bed rest, 60 days of bed rest, as well as in the patient population, long COVID, and the ME/CFS populations. So we do see there is a similar reduction in exercise capacity, but the underlying mechanism seems to be different, because the mitochondrial function, we look specifically at mitochondria in this particular diagram. The mitochondrial function is reduced in patients of people undergoing bed rest, but as you see, the mitochondrial function in the skeletal muscle nicely linear relates to their maximum exercise capacity. It is on a perfect line. However, in patients with long COVID as well as ME/CFS, you do see hardly any relationship between the skeletal muscle adaptations and their exercise performance, suggesting there's really something else going on than just being physically inactive. So that's something that we are currently following up on and studying in more detail. So what's the project status right now? We have done already 25 patients with long COVID. We are already on, I think, 30 controls almost right now. So we're currently performing an ME/CFS group as part of this consortium, and we will broaden the collection of more biopsies when the biobank is up and running. We already are at about 20 patients so far. The PhD student, Braden Charlton, sits in the back. He is appointed as a PhD student for 3 more years on this project, and we have 1 more open position. We have some interest already from within the department. It depends a little bit on when we start also with collecting samples for the biobank when we fill this open position. There's been some news already because Braden did get a best oral presentation at the human physiology workshop at the ESA in Cologne last year. So also there's been some success. Planning, there will be some more media attention. There's a German news article coming out soon on the ZDF next week. We have some papers in preparation. We get invitations also to add on additional papers as part of the follow-up work of what we've just done. And we have some more, in the pipeline essentially. And of course, we're still collecting and performing data analysis. So that is, for me, the status update of the project, and I'm happy to take any questions. Thank you.
Yes, before we go to the closing remarks by the patient organization, Laura de Vries will be talking briefly. We'll take some questions on Rob's presentation.
How do you know that you measured PEM and not exercise intolerance?
Yes, that's a very good question. Okay, so there's one wording thing that I've realized recently. Exercise intolerance we now use it as the same as PEM, because if you're intolerant to exercise, it's similar as you were if you have an allergy or you're food intolerant. So we use that the term exercise intolerance now actually for PEM. But I think what you mean is with exercise capacity, or reduced exercise capacity, and distinguish between PEM and exercise, the reduced exercise capacity, right? So the idea there is that we take 2 biopsies. So we take a biopsy before the exercise test occurs, and that's an resting situation, and that allows us to do cross-sectional comparisons. The second biopsy that we take 1 day after the induction of post-exertional malaise, or the maximal exercise test that we do to induce the PEM, is used to compare with the first biopsy to see the changes that occur rapidly. And we now know that's also described in the publication, that there are contributing factors that may explain the reduced exercise capacity, and other factors are able to change quickly upon 2 days, or 1 day after exercise, that can explain the post-exertional malaise. So we think there are actually 2 pathophysiological mechanisms for both.
Thank you.
Yeah, hey, thank you for the presentation and compliments with all the media attention. I've actually maybe 2 questions.
Yep.
One is related to the research you're doing, and specifically on ME.
Yep.
How can we, with the ME result, get the same kind of media attention that we have with long COVID? Well, the fear, right, that it dissipates, because we have similar results with what you had already 30 years ago in the beginning of the 90s, right? So the fear is that it dissipates, and we have no real cause, we have no real thing like. So how can we actually use your research in order to get the attention of ME?
Simple answer I would say right now is that within the long COVID pandemic, or the thing that happens right now is it attracts a lot of attention. We do use the ME as a sort of follow-up work. And of course, you can go back and you can say, well, if you do a lot of work on ME, you can relate it back to also the long COVID patients that are, they're everywhere around the world right now. So I think it's, we do think that long COVID is part of the umbrella term ME/CFS. And if you then go back essentially to the ME/CFS, you relate it back to the long COVID, you can actually, you get that same sort of.
No, I understand the principle, but my general is maybe we need also a media strategy around all the research that we're doing in order to try to capture and keep the attention, because it's not long COVID, it is ME, and how do we actually get that? So maybe a kind of media strategy around it, and the results might be useful.
Yeah. So that's something, of course, that we are in the forefront essentially with now publishing results from our consortium essentially. I think in the next year or when more data comes out, this is definitely something to keep an eye on. Yeah.
And the second question is more, I haven't heard a lot about how you define ME patients. And so what criteria, because it might be very hard in the brain bank to say, well, we've got a brain, and what was exactly the ME phenotype that we got, and how do you define? And it will be very hard to actually translate that into mice as well, right? So defining, and when you do research, trying to actually narrow it down as much as possible to get the best chance of results is critical.
I think there's we within the consortium we talk a lot about this, and I'm not probably the best person to say exactly what the diagnosis should be, but we have a inclusion criteria and exclusion criteria for the Biobank. In our particular work, because we're interested in post-exertional malaise, all patients had to experience this So we do have questionnaires to rule out that the patient had to undergo post-surgical malaise, a specific symptom, and I think that's a very specific symptom for both ME, CFS as well as long-COVID. But yes, there is more, but that's part of the larger biobank questions or discussions that we're having right now.
Yeah. Okay, it's a generic question of all the present. I haven't heard a lot about how the definition was today.
But there are talks about this, and I think I'm not the best person to explain it, but like there are maybe.
We're going with the CCC criteria, IOM, and CD94 with PAM, and that are main and ICC. So these are main criteria, either or, and we also try to have a balanced inclusion. So in general, the idea is that if you fit the CDC94 criteria, you have you have a lighter form of a CVS, and so we also try to make sure that the biobank doesn't become overpopulated with milder. So you have to have the full proportionate distribution of inclusion criteria. But
try to narrow it as much as possible, right?
Narrow, but also make it broad, because researchers must be able to. Sorry.
Know when it's.
Yeah, exactly. Yeah. So researchers in their specific research proposals said we only include people when they have a CCC criterion. So for the specific studies, they're very specific. For the biobank, you want to be broad.
In the biobank.
Yes, we do. We do stratify in the biobank. Yeah.
Okay.
So Rob, I didn't get. Do you do a double exercise test?
No.
24 hours.
No, that's a very good question. So the protocol design is as such. It's followed up from the 2-day exercise test that is typically used to diagnose PAM, but it doesn't really give you any clues of what really happens inside the body, because you do two exercise tests one day after each other. So instead of doing a 2-day exercise test, what we actually did is what we will do in the follow-up studies is to do a 2-day biopsy test or a 2-day blood test. So we do take a biopsy before an exercise test, then we induce the post-surgical malaise, and then 1 day later we ask the patients to come back to the lab to take another muscle biopsy and to take more blood, so that we can figure out exactly what is going on inside the body after 1 day of exercise. And so instead of doing a 2-day exercise test, we do a 2-day biopsy collection test.
And you get the same results as with a.
No, so with the 2-day exercise test, what people have seen in the past is that the people are more fatigable essentially, or more easily fatigable. So their maximal capacity is reduced, and that there is a peripheral contribution of that PAM essentially, and that's exactly what we focus on in the study. So we follow up essentially on the work that has been done on the exercise test, but we dive deeper into the skeletal muscle. What is then there different?
With how many time differences?
Sorry?
With how many time differences?
So we do 24 hours after the exercise.
And not 48 hours again.
No, we thought about this, but logistically that's difficult, because then the timing of the biopsy needs to be on a different day, and then we need to get the surgeon to come back, and then it's a bit complicated. So we choose for 24-hour time point.
Now, another thing I just want to hand over to you. It is extremely important that you define post-exertional malaise in detail. That's absolutely necessary. I didn't get it done in the Health Council Committee. We didn't arrive to, not even in the steering group of AutonoME. It is extremely important that you exactly define what is post-exertional malaise. Because there are psychiatrists who see ME patients who say, well, my MS patients have post-exertional malaise also, because they get tired after an exertion. So you should absolutely define that precisely.
So I can comment on that. I mean, everyone who does exercise is going to be fatigued for 10-15 minutes to up to an hour, or maybe 2 hours even after exercise. So Fatigue after exertion is not the right definition. So what we use is the worsening of symptoms, like at least 1 day after the onset of the 1 day after exercise, and that we score also what are the symptoms that people are reporting. Unfortunately, we don't have a sort of scaling in this, so we don't know whether someone suffers from a little bit of PEM and others from super much PEM. We just can score their symptoms, their increase in symptoms.
Yeah, I've got a quite simple question. You're lucky, yeah? You need a microphone if you want it. That is, now we've got some more insights and some more publicity, which explains that increasing activity is not a good idea for someone with PEM. Somehow this notion that you can use activity and increase it to cure people is quite sticky.
Yep.
Can we somehow use this to change these sort of protocols and at least identify patients to overcome this?
Yeah.
And this is a no-brainer, of course, but it's difficult.
Yeah, within this room, I think most people will agree with this. The first thought that exercise is not good for you, I think that, I mean, it's the intensity that is important. So you don't want to go over the intensity where post-exertional is being induced. Below that intensity, of course, we think that exercise is still good for you. So yes, patients need to keep their boundaries, protect their boundaries. Now that is something that is actually interestingly well known in the not in the physiotherapy field right now in the long COVID patients, that patients need to keep the boundaries. So yes, this work actually just adds on and gives experimental evidence for that notion. And yes, there is within the rehabilitation scientists and the physiotherapists, of course, there has been some stir about this publication because maybe they are doing something that can be negative for them. But I think that helps with the discussion that maybe exercise is not the cure for those patients.
Still allowed for one question?
I have 2 patients working waiting online. I want to get some power.
We have 2 questions from the people online.
Yeah.
So the first question is, someone is curious about the reaction on the article you published, and if there was any media attention from is it a physician organization?
Artsorganisatie, yeah. First question first. So 90% of the comments, or 95% of the comments, were very positive. Particularly from the patient population, they feel recognized that there is something going on in the body, etc., etc. There has been, of course, you always get the anti-vaxxers. That's standard. Yeah, that's just how it is. You also do get, the critical colleagues, so to say. So maybe your patients were inactive, maybe it was just inactivity. Now, with the work that we're currently doing, we can debunk that idea at least. So yes, there has been some critical comments, of course, and I think, I'm completely aware, because we work on this for more than 2 years. I'm completely aware of that it's not the answer and it's not perfect. And yeah, of course, there's follow-up questions to be done. That's for later. Physicians, there has been some follow-up reports in medical medisch contact. I think there's been some things written. Sports rehabilitation or sports medicine, sportgeneeskunde also wrote a article about this, and I've been also invited to some conferences for physicians and also train GPs, for instance, on this matter.
Yeah, and about the artsorganisatie?
Yeah, so that's our artsorganisatie. So there has been some contact also in medisch contact and some follow-up presentations at conferences. Yeah.
Perfect. There are some more questions. I think we have to follow up that later. Maybe we can send them to you by mail, and then you can reply to it, or maybe
if I sit on your desk, on your chair, then I can also type.
Perfect. Then we will give the floor to for the closing remark.
Yeah, so we will now give the word to Laura de Vries, indeed, who has prepared a presentation as a patient representative and will give you an overview into the patient perspective.
So Laura, I will ask you to share your own slides so that we can also see you. I think that's a bit nicer than only the slides.
Zoals ik al zei, de patiëntenorganisaties hebben mij gevraagd om mijn verhaal te vertellen. En ja, eigenlijk elk goed verhaal begint met er was eens. En in mijn geval was dat er was dus een dokter die niks over ME/CVS wist totdat ze het zelf kreeg. En eigenlijk zelfs toen ik het kreeg, er nog niks van wist en er eigenlijk ook niks over wilde horen. En dat heeft een tijdje geduurd. Mijn ME/CVS verhaal, laat ik het zo zeggen, begint in 2018. Ik viel uit op mijn werk en ik heb opgeschreven, ik was voorbij moe. En dat is eigenlijk voor mij wat ik altijd heb gezegd. Moeheid is echt niks bij wat je voelt als je ME/CVS-patiënt bent. Het is een alles omvattende uitputting eigenlijk. Maar goed, ik werkte als artsassistent. Ik was net gepromoveerd. Mijn vader was dat jaar ziek geweest. Dus druk leven. Zoals dat, dus wat natuurlijk het eerste wordt gezegd, je hebt vast een burn-out. Dat was natuurlijk ook wel in principe had dat een logische conclusie kunnen zijn. Dus ik deed wat je doet als je een burn-out hebt. Ik ging eerst met coaches in zee en toen met psychotherapeuten. Toen met een psychosomatische fysiotherapeut. Ik heb mijn hele ziel van binnen naar buiten gekeerd en weer terug. En eigenlijk werd altijd gezegd, nou, als je gewoon mentaal weer beter bent, dan moet je fysiek ook weer beter worden. En ik bleef maar naar therapie gaan en ik bleef maar die fysiotherapie doen. En ik had zelf wel het idee dat ik gewoon steeds mentaal sterker in mijn vel zat, maar dat er fysiek dus eigenlijk gewoon niks gebeurde. Sterker nog, ik ging fysiek achteruit. En in het begin denk je, ik doe niet hard genoeg mijn best, ik doe niet genoeg, ik mediteer niet genoeg, ik wandel niet genoeg. Maar op een gegeven moment, na dus toch wel een jaar 4, en dan hebben we het dus over 4 jaar, dacht ik op een gegeven moment wel van, dit is wel heel raar, want de discrepantie werd eigenlijk steeds groter. Dus dat ik me gewoon mentaal heel stabiel voelde, maar wel fysiek steeds verder achteruit ging. En toen ontmoette ik in 2022 een huisarts met de ziekte van Lyme, en die bij die Lyme ook ME/CVS heeft. En die zei tegen mij, heb je eigenlijk geen ME/CVS? Ik zei, nee joh, dat heb ik niet, nee, want het is psychisch. En ik moet gewoon harder mijn best doen met therapie. En nee joh, dat heb ik echt niet. Dus en zij blijft het af en toe zo een keer een beetje aan mij, een beetje zo mij daarmee bestoken. Toen dacht ik, oké, misschien moet ik toch eens wat erover gaan lezen. Want eigenlijk had ik in de opleiding helemaal niks over ME/CVS geleerd. Het enige wat ik wist is dat het mensen waren die moe waren. En ik had zo'n vaag idee van, dat zijn die mensen die altijd moe zijn, maar die zeggen dat het iets met het immuunsysteem is. Maar dat was een beetje wat ik ervan wist, zeg maar. Ik ben in 2007 begonnen met de studie geneeskunde, dus dat is eigenlijk helemaal nog niet zo heel lang geleden. Dus dat geeft ook wel iets aan over hoe ik als arts ben opgeleid over deze ziekte. Maar goed, dus ik ging er wat over lezen. En toen dacht ik, jeetje. En steeds meer, hoe meer ik las, hoe meer ik dacht, dit is wel heel eng. Het is echt precies wat ik heb. Het is echt precies wat ik heb. Oh, dat symptoom ook. Oh, dat symptoom ook. Oh, en daarom ben ik elke keer pas een paar dagen nadat ik iets doe moe. Ik wist ook niet van het bestaan van PEM af. Ik wist het niet. Dus toen ik voor het eerst over PEM las, toen viel ik echt, ik viel bijna achterover van verbazing dat ik dat had. En uiteindelijk ben ik lid geworden van een lotgenotengroep met artsen, waarin artsen zitten met voornamelijk long-covid, maar toen ook al een aantal met ME, maar dat was nog een veel kleiner clubje. En toen ik met hen ging praten, toen schrok ik weer, want zij hadden echt exact dezelfde dingen als ik. Dezelfde slaapproblemen, dezelfde maag-darmproblemen, dezelfde, de PEM. Ik leerde over POTS, waarvan ik ook het bestaan niet van wist. Dus posturaal orthostatic tachycardia syndroom. Dus dat je vaten eigenlijk niet tegen de zwaartekracht je bloed goed omhoog kunnen pompen. Dus dat je eigenlijk last hebt van de zwaartekracht. Dus dat je hart dan heel erg hard gaat kloppen. Nou, dat had ik ook. Ja, ik dacht natuurlijk dat ik hartkloppingen had, dat het psychisch was. Dus langzaam maar zeker viel bij mij het kwartje eigenlijk. En toen ben ik pas begin 2023, dus dat is eigenlijk pas een jaar geleden, naar de internist gegaan in Nijmegen in het Radboud. En die heeft bij mij de diagnose ME/CVS gesteld. En waar komt het dan door, was natuurlijk de vraag. Natuurlijk bij sommige patiënten, ME-patiënten, komt het soort van uit het niets als het ware. Maar bij mij is het waarschijnlijk veroorzaakt door een Giardia-infectie. Ik was in het begin van 2018 in Oeganda geweest en had daar een Giardia-infectie opgelopen, waar ik ook heel veel maag-darmklachten van aan had overgehouden. En er zijn Noorse studies die laten zien dat patiënten met een Giardia-infectie ook, wat ze in de studie zeggen, chronisch vermoeidheid, maar dus ME kunnen krijgen. Dus waarschijnlijk is het bij mij daardoor veroorzaakt. Ja, toen had ik een diagnose. Dat was een opluchting, want ik begreep eindelijk dat het dus niet aan mij lag. Dat ik niet goed mijn best deed met alle therapieën die ik kreeg. Maar het was ook het begin van een rouwproces. Want opeens had ik een ziekte zonder toekomst. Een ziekte die niet behandelbaar is op dit moment. Een heel invaliderende ziekte. Dus ja, het was eigenlijk een double-edged sword. Het was aan de ene kant heel fijn, maar aan de andere kant ook heel confronterend. En ik kwam natuurlijk, je ziet op dit plaatje ook, als je mij ziet als jonge dokter, zeg maar, met een mooi lekker kleurtje op mijn gezicht. Blonde haren van het fietsen. Ik fietste veel mijn racefiets. Ik deed leuke dingen. Ja, en dan ben je dus, en ik was natuurlijk al wel 5 jaar ziek, maar dat verschil is zo ontzettend groot. Dat is dus de volgende slide. Nou ja, dit is eigenlijk hoe mijn leven er nu uitziet. Ik lig denk ik ongeveer 20 tot 22 uur per dag, afhankelijk van hoe goed ik me voel, lig ik op de bank. Ik zit op dit moment ook op de bank met mijn benen lang uitgestrekt, omdat dus door de POTS het voor mij niet mogelijk is om mijn benen lang verticaal te houden. Dus ik lig vaak zo met dit is Nox, mijn kat, die je ziet. Ik heb snel last van prikkels, dus ik lig vaak met een noise cancelling koptelefoon op. En ik ben eigenlijk min of meer aan huis gebonden, wat betekent dat ik wel een beetje nog hier in huis kan rondscharrelen, maar als ik de deur uit wil, ik kan nog maar een paar meter lopen. Dus dan moet ik dus met de rolstoel, zoals je hier ziet, op dit plaatje ga ik stemmen. En mijn vader die duwt mij met de rolstoel. En ik woon in Arnhem en het is behoorlijk heuvelachtig. Dus die, als een soort heigend paard, duwde die mij de bult op. Ik heb ook een scootmobiel, maar die staat wat verder weg. En daar kan ik nu helaas niet meer naartoe lopen. Dus, dus het leven ziet er voor mij echt heel anders uit dan voordat ik ziek werd. En je ziet hier nog 2 plaatjes van een douche met een kruisje erdoorheen. En een pannetje met een kruisje erdoorheen. Simpele dingen als onder de douche gaan en eten koken zijn voor mij eigenlijk ook gewoon niet simpel meer. Als ik douche, ik heb nu de laatste keer dat ik mijn haar heb gewassen was op 20 november. Een week na de verjaardag van mijn moeder. Waar ik niet van tevoren durfde mijn haren te wassen, want ik was bang dat ik zo hard zou crashen, zoveel PEM zou krijgen. Dat ik niet naar die verjaardag zou kunnen gaan. Douchen is echt het meest zware voor ME-CVS en ook long-covid-patiënten met POTS, omdat het warm is. Je kan niet helemaal plat liggen. Het is echt, je vaten gaan openstaan. Het is echt verschrikkelijk. En eten koken. Mijn vader kookt 4 keer in de week eten voor mij. Ik heb 1 keer in de week wordt er door iemand van de buurt voor mij gekookt. En de andere 2 dagen eet ik brood of pizza of sla of iets wat ik gewoon snel... omdat ik gewoon eigenlijk niet zo lang meer in die keuken kan zitten of staan. Zitten op een kreuken of staan. Dus eigenlijk ben ik van een heel actief iemand die midden in het leven stond. Is mijn leven heel klein en heel beperkt geworden. En dat is denk ik... daarom staat er ook een wereld van verschil. Ik heb ook het gevoel dat ik 2 levens heb gehad als het ware. Het leven voor ME en het leven na ME. En dat het gewoon in geen enkele manier met elkaar te vergelijken is. Ik heb natuurlijk nu mijn verhaal verteld. En mijn verhaal is eigenlijk voor een ME-verhaal best wel standaard. Ik ben een vrouw. 3 keer zoveel vrouwen krijgen ME als mannen. Het begint, dit heb ik uit het artikel van Bateman, een van de ME-specialisten van Amerika, maar het begint meestal tussen 30e en 39e levensjaar. Ik was 32 toen ik begon. En het is vaak post-infectieus. Dus ik ben eigenlijk redelijk standaard. En dat is voor sommigen nog wel te begrijpen. Maar er zijn ook heel veel patiënten die niet standaard zijn. De mannen, ik heb ze er nu niet bij gezet, maar misschien gedraagt ME zich bij mannen wel heel erg anders dan bij vrouwen. Het onderzoek wordt voor een groot deel nog steeds alleen bij vrouwen gedaan. Ik zag dat Brent en Rob hebben wel ook gelijk aantal mannen en vrouwen in hun PAM-studie. Dus dat is echt supergoed. Maar er zijn dus ook patiënten waarvan de infectie niet bekend is. Die een soort sluipend begin hebben. Of patiënten die het gekregen hebben na een operatie of na een ongeluk of na een vaccinatie. En die hebben nog veel meer moeite om te vertellen dat ze dit, of om mensen te laten geloven dat ze dit hebben. Omdat het zo vaag is voor mensen. En ja, hoe krijg je dan zo'n intense ziekte van iets wat eigenlijk gewoon voor heel veel mensen gewoon normaal is. En als laatste natuurlijk de kinderen en de jongeren. Dat werd eerder ook al gevraagd vandaag. Dat vind ik zelf eigenlijk nog het meest schrijnend. Nou ja, wat ik zei, ik was 32 toen ik gediagnosticeerd werd. En ik heb al heel erg gevoeld dat ik nog heel veel, ik ben nu 37, dat ik heel veel in mijn leven mis. Heel veel ervaringen. Maar die jongeren, die jongens, die meiden van 15, 16, moet je voorstellen dat je niet naar school kan. Dat je niet naar verjaardagsfeestjes kan van je vrienden. Dat je niet kan sporten. Dat je niet naar een schoolfeest kan. Als ik daaraan denk, ik krijg oprecht, jullie kunnen het niet zien, maar kippenvel. Want het is zo ontzettend, ja, eigenlijk is het zo verdrietig. En nou ja, en dan ben ik ergens soort van dankbaar dat ik pas op mijn 32e ziek ben geworden. Maar des te belangrijker dat we ook die kinderen niet vergeten. Want het is echt enorm schrijnend. Volgende slide.
Ja.
Nou, hier hebben we natuurlijk ook al meerdere sprekers het over gehad. Dat ME, CVS in verschillende gradaties kan voorkomen. Nou, dat kunnen jullie zien in het midden als het ware op de slide. En het lastige is eigenlijk dat in alle stadia van ME patiënten onzichtbaar zijn. Dat ze bij milde ME, waar het vaak mee begint, trouwens niet altijd. Sommige mensen beginnen ook meteen met matig of ernstig ME, maar sommigen beginnen met milde ME en dat wordt vaak gewoon niet herkend. Mensen zien er gezond uit. Je ziet hier een fotootje van mij tijdens mijn promotieceremonie. Dit was in april 2018, 3 maanden voordat ik uitviel. En ik was hier eigenlijk al hartstikke ziek. Ik zat daar te smilen, maar ik stond op de borrel na mijn promotie en ik dacht alleen maar, ik wil dat iedereen naar huis gaat. Ik had zoveel pijn aan mijn benen, pijn aan mijn schouders, pijn aan mijn hoofd. Ik kon eigenlijk gewoon geen stap meer zetten. Maar je zag het niet, want ik zag er verder gewoon, nou ja, je ziet het is een stralende vrouw. Dus, en dat zorgt dus ook heel vaak voor dat het dus gewoon niet onderkend wordt. En ik ook diagnose angststoornis, depressie, persoonlijkheidsstoornissen zijn bij mij, burn-out, ze zijn bij mij allemaal langsgekomen. Simpelweg omdat mensen gewoon niet kunnen geloven dat zo'n jonge, nou ja, gezonde vrouw zo'n ziekte kan hebben. En aan de andere kant van het spectrum heb je natuurlijk de patiënten met zeer ernstige en zeer ernstige ME. En die zijn ook niet zichtbaar. Want die liggen thuis in hun donkere kamers. Die zijn aan bed gebonden, aan huis gebonden. Mensen met zeer ernstige ME kunnen ook eigenlijk niemand meer verdragen. Geen mensen om zich heen. Liggen in een donkere kamer, 24 uur per dag. Sommigen kunnen niemand verdragen. Sommigen misschien 5 minuten iemand per dag. Moet je voorstellen hoe klein je wereld dan is. En hoe onzichtbaar je dan ook bent. En dat is ook, als je kijkt naar de kwaliteit van leven van die mensen. Dat hebben ze ook wel uitgezet in verschillende studies. Is het vergelijkbaar met mensen die bijna doodgaan eigenlijk. Die in een palliatief traject zitten. Mensen met vergevorderd stadium van AIDS. Het is echt, dat zijn mensen die heel ziek zijn. En heel veel pijn hebben. En niet meer kunnen eten. En gevoed worden door zondes. En je ziet op dit plaatje, dit is Whitney DeVoe. Dat is een Amerikaanse ME-patiënt. Hij heeft ook ernstige ME. Zijn vader is Ron Davis, een Stanford-professor. En die doet ook onderzoek naar ME. Natuurlijk omdat zijn zoon dat heeft. Maar goed, die mensen met ernstig ME, die zijn dus gewoon niet zichtbaar voor de maatschappij. En en dus ook niet voor hun dokters. Nou, dat werd ook al, ik vond dat in het praatje van de UK-onderzoekscohort werd dat ook heel mooi gezegd. Die mensen zien soms jaren geen dokters, geen verpleegkundigen, geen thuiszorg, die zijn gewoon helemaal geïsoleerd. Helemaal uit beeld, helemaal onzichtbaar. En ze noemen zich dan ook niet voor niks de millions missing, want dat is ook echt zo. En ik zou bijna willen zeggen billions missing, want ik denk dat we inmiddels wereldwijd echt over heel veel mensen spreken. Volgende slide. Dus ja, dit is eigenlijk de conclusie. ME-patiënten zijn gewoon onzichtbaar voor de maatschappij. En dat is gewoon iets wat de zwaarte van de ziekte gewoon heel groot maakt. Dat je dus niet serieus genomen wordt en niet zichtbaar bent. Volgende slide. Nou, dit plaatje, hier staat natuurlijk leven met ME/CVS, is leven met verlies. Nu wordt ook wel levend verlies genoemd. Je ziet een plaatje van mij. Dit is een actie in het kader van de niet hersteld actie. Zij laten plaatjes zien van patiënten met PAIS, met post-acute infectieuze syndromen zoals ME/CVS en long-covid en Lyme. En ze vragen je dan, waar word je gemist in je leven? Wat mis je? Dus zij hebben honderden plaatjes van dit soort mensen die dus uit hun eigen leven zijn geknipt eigenlijk. Het zijn moeders met kinderen, het zijn, je kan het zo gek niet bedenken, allemaal. Als je naar de Instagram of Facebook of LinkedIn pagina van Niet Hersteld gaat, kan je al die foto's zien. Ik vind het zelf heel indrukwekkend. En ik ben dit op dit plaatje. Ik ben hier in Engeland een hele lange wandeling met een goede vriendin aan het maken. En dat is iets wat ik... we deden een hele lange wandeling van 1000 kilometer. En we zouden dat elk jaar een stukje doen. Maar we zijn helaas maar 2 keer geweest, omdat ik daarna ziek werd. Dus dat is voor mij bijvoorbeeld een heel groot gemis, dat ik niet meer naar buiten kan. En als je dan kijkt naar deze hele rij van dingen die je verliest als je ME/CVS hebt, dat zijn er nogal wat. Allereerst het eerste gewoon van leven in een gezond lijf. Gewoon klachtenvrij zijn, je lekker voelen in je lijf. Dat is zoiets universeels, essentieels als het ware. Iets wat ik misschien nog wel het moeilijkste vind uit te leggen. Dat je wakker wordt en dat je niet denkt, oh lekker, de dag begint. Maar dat je denkt, hoofdpijn, misselijk. Het duurt bij mij ook altijd wel, in ieder geval wel 1 uur, 1,5 voordat ik een beetje op gang ben. Dan drink ik bijna een liter water met elektrolyten voor mijn pots, om de volumestatus weer een beetje op peil te brengen, zeg maar. En dan ben ik weer een beetje aanspreekbaar. Maar het gevoel, om elke dag het gevoel te hebben dat je lijf eigenlijk niet goed is, dat er iets gewoon niet, dat is zo'n, het is zo'n, ik kan er even geen woord voor vinden, maar het is zo moeilijk te beschrijven wat dat is, dat je nooit gewoon een dag lekker voelt. En alle andere dingen, dat is ook natuurlijk ook wel genoemd in eerdere presentaties, het verlies van inkomen, werk, het verlies van sociale rollen, zelfstandigheid, autonomie. Eigenlijk spreekt het allemaal, voor mij spreekt het voor zich, maar je moet er even bij stilstaan wat je allemaal verliest als je deze ziekte hebt. Voor mij betekent het bijvoorbeeld dat ik was arts, ik werkte als arts en dit jaar verloopt mijn registratie. Dus dat betekent dat het gewoon klaar is met mijn werk als arts. Als ik ooit beter word, kan ik misschien weer opnieuw registreren, maar ik ben gewoon al mijn werk daarvoor ben ik gewoon kwijt. Ik zou heel graag moeder willen worden, maar dat kan nu gewoon niet. Dus de rol van moeder gaat nu ook aan mij voorbij. En dingen als zelfstandigheid en autonomie en spontaniteit. Je moet altijd nadenken, hoe verdeel ik mijn energie? Hoe zorg ik ervoor dat ik niet crash? Kan ik misschien een uurtje met een vriendin afspreken die dan bij mij een kopje thee kan drinken? Ja, maar dan kan ik dus eigenlijk niet ook nog een tekening maken vanmiddag. Of zal ik vandaag gaan douchen? Nou, dan moet ik dus 3 dagen denken dat ik gewoon gecrashed ben daarna, omdat douchen zo zwaar is. Dus het is altijd, je leven is altijd op een weegschaal. Je bent altijd aan het denken van, wat kan ik wel, wat kan ik niet? Je kan nooit eens even spontaan, soms dan wil ik echt mijn deur uitrennen en gewoon even een rondje rond het blok rennen. Maar ja, ik zou wel hartstikke dom zijn als ik dat deed natuurlijk. Want Rob heeft jullie net gezien wat er met je spieren gebeurt als ME long-covid patiënt als je dat doet. Dus dat doe ik niet. Maar dat gevoel van gevangen te zitten in je huis, in je lijf, in je leven, dat is gewoon best echt heel sterk. En daarom zijn er ook patiënten, vooral patiënten natuurlijk met ernstige ME/CVS, die op een gegeven moment zeggen, ik wil niet meer. Die ervoor kiezen, in landen waar dat kan, om euthanasie te laten plegen. Maar in landen waar dat niet kan, dus af en toe zijn er ook gevallen van mensen die zelfmoord plegen. En dat is iets, ik post regelmatig op LinkedIn dingen over mijn ziekte. En op een gegeven moment zei iemand tegen mij, ja, maar MS van ME word je, ik had gezegd dat ik doodziek was. En toen zei iemand, nee, je wordt niet doodziek, want je gaat er niet aan dood. En toen dacht ik, ja, nee, de meeste niet, nee. Maar een aantal wel. En je bent wel gewoon een heel leven doodziek. Dus als er geen behandeling is. Dus het is nogal wat. Een slide. Maar goed, de laatste 2 punten op deze lijst vind ik eigenlijk het meest relevant voor de mensen die vandaag hier in de zaal zitten. Dat wat ik zelf heel erg heb gemerkt vanaf het moment dat ik ME-patiënt werd, dat ik gewoon minder serieus genomen werd. Zowel in mijn ziektebeleving als in de keuzes die ik maak voor mijzelf en mijn ziekte. Wat ik zei, ik ben gepromoveerd bij de interne geneeskunde. Ik weet veel van de menselijke fysiologie. Over het algemeen werd ik beschouwd als iemand die daar best verstand van had en je daar ook best wel wat over kan vragen. En ik lees nu, als het lukt, zeg maar, af en toe nog wat papers natuurlijk. Maar als ik dat dan deel met oud-studiegenoten, krijg ik soms echt de meest betuttelende reacties. Zo van net alsof je mens zijn of zo ook niet meer bestaat op het moment dat je een ziekte hebt die nog niet kan worden verklaard. Alsof je geen eigen ideeën meer hebt, geen eigen verstand, geen eigen wil, geen eigen... alsof je een soort dom schaapje bent geworden of zo. En ik vertelde ook bijvoorbeeld een oud studiegenoot over PEM en dat ik dus heel voorzichtig ben met bewegen. En toen zei ze, ja, nou, als je op die bank blijft liggen, dan ga je er ook gewoon dood. Dus je moet gewoon bewegen. Nou, het feit dat mensen dat soort dingen tegen je zeggen, is gewoon zo kwetsend. En ik heb dan nog het geluk dat ik arts ben, dat ik ingelezen ben, dat ik kan vertellen wat er aan de hand is. Dat ik de literatuur onder mijn eigen huisarts haar neus kan duwen en dat ook geregeld doe. Ik heb trouwens een fantastische huisarts. Maar daar ben ik echt zeker niet, ben ik zeker wel een uitzondering in. Want er zijn ook echt heel veel patiënten die nog heel veel moeite hebben om gehoord te worden door hun huisartsen, door hun medisch specialisten, van het kastje naar de muur worden gestuurd. Ik trof een internist die geloofde in ME/CVS en mij die diagnose ook wilde geven, maar er zijn er ook heel veel die dat gewoon nog niet doen. En ik ken ook verhalen van lotgenoten van mij die pas bij de 3e internist de diagnose kreeg. Ja, dat kan je gewoon bijna niet voorstellen, dat je opeens een soort liability bent. Je wordt gewoon weggestopt, in een hoekje gestopt. Je ziekte wordt gebagatelliseerd, je wordt gemarginaliseerd. En het gaat wel sinds de komst van long covid voor mijn gevoel langzaam iets beter. Omdat er meer begrip komt voor post-acute infectieuze syndromen. Maar we zijn er echt nog niet. We zijn er echt nog niet. Echt dagelijks hoor ik verhalen van patiënten met long covid en ME die echt ontzettend lijden, niet serieus worden genomen. Dus ik denk, als ik iets moet zeggen van deze ziekte, van alle dingen die ik verloren heb, is dit voor mij, denk ik, eigenlijk wel het belangrijkste. En denk ik voor heel veel patiënten belangrijk. Je kan dan wel ziek zijn en je kan dan wel al die dingen verloren hebben, maar op het moment dat niemand je daarin gelooft, dan is het pas pijnlijk. En dan is het lijden, dan is het eigenlijk, wat zeggen ze altijd, insult upon injury. Dus het is een tweede laag bovenop het lijden van de ziekte, als het ware. En ik denk gewoon dat deze 2 dingen, en er is dus geen perspectief, dat deze 2 dingen met beter onderzoek, en dan wil ik dus graag naar de laatste slide, dat ons moet gaan helpen. Je ziet hier Pandora. En voor degenen die het verhaal niet kennen, Pandora had een doos of een kruik, het verhaal verschilt een beetje, van de goden gekregen. En de goden hadden daar alle slechte dingen van de wereld in gestopt. En ze hadden tegen Pandora gezegd, je mag die doos niet openmaken. Maar goed, Pandora was natuurlijk nieuwsgierig. En die maakte de doos wel open. En toen kwamen alle slechte dingen van de wereld kwamen vrij. En dat was natuurlijk heel ellendig. Maar uiteindelijk, dat wat er in de doos overbleef, was hoop. En dat is eigenlijk ook hoe het voor mij is. Wij hebben ME-CVS-patiënten de afgelopen decennia, denk ik, alle evils van de wereld wel gezien. Ik ben pas 6 jaar ziek, maar ik ken ook mensen die 10, 20, 30 jaar ziek zijn. Die hebben alles meegemaakt. Alle slechte dingen die je maar kan bedenken. Achteruit gegaan door therapieën. Nou ja, goed. Ik zal niet in details treden, want ik denk dat de meeste van de mensen in de zaal weten waar het over gaat. Maar er is ook hoop. En daarom vind ik het verhaal van Pandora zo mooi. Er is ook hoop. Want als er onderzoek komt... er is natuurlijk internationaal al heel veel onderzoek. Maar als Nederland daar ook een rol in gaat spelen... dan gaan we ook zien, denk ik, dat we in Nederland... dat artsen ons meer serieus gaan nemen. We hebben natuurlijk gezien afgelopen week... dat Rob natuurlijk in de media was met zijn hele... met zijn nature study. Dat gaat ons... En daarom vond ik trouwens ook die vraag over hoe gaan we de mediastrategie doen... ten opzichte van... of ten aanzien van ME. Hoe krijgen we nou dit ook zichtbaar? Want dat is denk ik gewoon de grootste uitdaging. Dat wij altijd onzichtbaar zijn gebleven. En als er goed onderzoek komt in Nederland. Wat ook breed gedragen wordt. Wat breed uitgedragen wordt. Dan zou het wel eens kunnen dat dat gewoon beter wordt. En dat is natuurlijk waar wij patiënten gewoon op hopen. Dat er begrip voor ons komt. Dat de ziekte wordt herkend door dokters. Maar ook erkend. En natuurlijk wat we natuurlijk het allerliefste willen is een behandeling. En ik weet dat dat misschien nog wel, nog een verre droom is. Maar je mag altijd hopen, denk ik. En dat is toch uiteindelijk waar je naartoe wil. Dat deze enorme invaliderende ziekte, dat behandeld kan worden. En misschien in eerste instantie dat in ieder geval het proces stilgezet kan worden. Ik weet niet. Ik heb ook nog geen idee... Ik heb heel veel ideeën over hoe dit in elkaar zou kunnen zitten, maar ik weet nog niet het precieze idee. Maar dus dat je, dat zal in stappen gaan, net zoals het bij andere ziektes is gegaan in de geschiedenis. Maar de stappen moeten wel worden gezet. En als dat gebeurt, dan heb ik hoop. En dan hoop ik ook dat Nederland internationaal gaat meedoen. En dat ze gaan luisteren naar degenen die al langer bezig zijn, professor Scheibenboog in Duitsland, de groepen in Amerika, professor Bergquist die er is, de groep in de UK die vandaag gesproken heeft. We kunnen zoveel al leren van de mensen om ons heen. En in Nederland zijn we toch heel lang achterlopers geweest als het gaat over biomedisch onderzoek naar ME. We hebben heel lang in de psychologische hoek gezeten met ons onderzoek. Maar ik denk dat het tijd is dat daar een eind aan komt. Dus ik heb niet voor niks op deze presentatie gezet van achterloper naar voorloper, want dat is wat ik hoop. Dank jullie wel. En als jullie vragen hebben... Oh.
Ja, ik wil zeggen, wil je bedanken voor je hele persoonlijke verhaal. Ik weet dat je hier veel voorbereid hebt en dat het veel energie kost. En het is ook... maakt het ons niet makkelijk, we moeten alles waar gaan maken. Dat is wordt er ook wel aan ons gedacht. Nou, ik vind het heel fijn dat je hier wilde spreken en ik waardeer het enorm. Als er nog vragen of opmerkingen zijn uit de zaal? Ik denk dat het heel helder en een duidelijk verhaal was. En nogmaals, we zijn dankbaar voor je persoonlijke, dat je dit met ons wilt delen. Ja.
Nou, heel graag gedaan.
We houden contact, is te zeggen. Ja, dat zie ik. Dankjewel. Oké, dan wil ik deze... switch it back to English. I want to close this afternoon. There's still drinks and bites next door, if I'm correct. They did take it away. And I'm very grateful that you all came here and joined us at this kickoff meeting. So it's a bittersweet thing, right? We have to deal with disease clearly causes a lot of suffering, tremendous amount of suffering. At the same time, we're very joyful that we can hopefully make a change and do it in a meaningful and righteous way. So thank you very much again, and I hope to talk to you one-to-one on this occasion. Thank you. Many thanks to Jessie and Leia and Kate for preparing all that stuff. Tremendous out of work. unbelievable. And all the people I forgot to thank.